Hello. Welcome to Zombocom. I'm just finishing up my lunch real quick here. While we wait for people to show up. Well, we're at 80, so I guess we can start. So, if you saw in the weekend streams, made some good progress on the Voxel engine. So I decided that, at least for this week, let's try to actually use the Voxel engine, work on the procedural generation, and make that be the primary project for this week. And then on Friday, I'm going to try to work on STB stuff because I'm way behind on merging fixes for those libraries. So over the weekend, we got set up the ability to change the textures. I accelerated the command list culling because it was getting slow with large inputs. And we added a new feature that allows us to recolor and retexture individual faces of voxels, so which you can see demoed here. This purple is a recoloring, and then there's other stripes here are retexturing, and they only affect they're supposed to only affect the why was I seeing? Oh, I was seeing it because I was stuck on the inside of it. But that does mean it's incorrectly texturing that face. I guess we should debug that. Retexture Z+2, Z+3. Oh, I'm doing it on all sides. 3XF is all sides. I want that on size 8. But let's also raise it up so we can check the back side. Okay, now it should be, yeah. It's only on one side. Yeah, and you can see it doesn't extend onto the past the corner, even though it's on this voxel. Now, our times have gotten really slow for meshing, and we can work on that, but this is running on a 980 Ti. And I've said that I suspect that doing this on the GPU is actually silly, and because we have a bunch of cores available, we could just dedicate a core to generating the stuff. But also, we can do this over time. We can spread out this computation. It doesn't need to be run every frame. We probably need to generate one of these every second or so when you're running. And so it can be spread out over that second and use less time per frame. Oops, and I have my phone on. Turn my ringer off. Um, just want to check, is the stream working correctly, since I'm not getting any feedback from anybody. There we go. If you worked on any AAA games or anything known, Thief, The Dark Project in the 90s. I also worked on Braid, which is John Blow's game before The Witness. I was the only other person who worked on it. I did a small amount of programming for it. Tiny contribution compared to his work. I worked at Epic, but I didn't work on Fortnite. Okay, so we have this recolor and retexturing feature. And I was thinking about stairs, because we have this tall building and we want to build stairs up it. So like the idea is let's just do it. What we want is we want a central core for the elevator. So we do p equals put. So let's see, x0 x1 0. Okay. So let's find the center. How big is an elevator? We can be a little small, especially because you can't get inside it, it's just for show essentially. Although maybe it won't be once you power up. So probably about 8 foot by 8 foot, let's say, just as a starting point at least. It starts at base +1. And then we go to x +4, y +4, and we go to base plus floors times floor height, but we don't want it to go through the ceiling, the roof, but we put the roof on afterwards, so that's fine. What P XYZ count. P XYZ count. Oh, base, not base. Base height, base Z base. Okay, so now that's a pretty tiny elevator shaft. And there isn't, oh, here it is. It's not drawn correctly? Oh, it's just invisible because of the texturing. Weird. Let's make these floors have different textures on all sides. So the texture is this. Pack tech. 2, 3, 4. See that. Okay, yeah, that's a lot more obvious. let's make it a little bit bigger. This is elevator shaft. This is roof. And then what we want to do is have stairs. So stairs could be maybe 5 foot wide. So let's make a hole for the stairs. So maybe 5 foot wide. So that goes from 11 to 6 to 5 to 7 to 5. 12 to 5. I guess it can go to 6, and then we'll put a slab in. And then here's the thing: to draw the stairs, we want this succession of, and we'd have to draw an awful lot of slabs to draw that. So what I think we'd want to do is actually make a stairs command, which is basically draw a big slab the size of the entire stairs that knows to put gaps in to only draw some of it. So I think that's the thing we've got to do here to make this be at all efficient. Because the problem with these little tiny slabs is then they don't get good parallelism when it's populating the textures. When it populates the texture grid. And they're such a core feature. We'll have to have them in every building. So, might as well. So, let's go to ideas. Oh, I had the idea to indirect these. Interesting. These are now only 11-bit. We went with 8-bit. That's what we ended up with. And then there's the recoloring retextures. And we haven't implemented these other ones yet. So we're going to do stairs. And we just keep all that. And then 2-bit orientation and 5-bit spacing. I think that looks like that uses up all the bits. So the orientation, the stairs can be sloping in 4 directions. And the spacing is the gap between, we're going to draw, the stairs will draw multiple levels of stairs It'll draw stairs, and then stairs above those, and stairs above those. So we actually need more than spacing. We also need thickness. How big would spacing reasonably be? You might do every other floor. With 16-foot floors, you would need to go up to 32. That's 5 bits. The spacing could be small if you were using this as a weird decorative thing or something. So I feel like maybe we steal bits from xlen and ylen. You could have big stairs, like outside. The other thing you could do is you could draw these if we show a side view. I was thinking what right now I've been picturing you can't see that part. I've been picturing that that's what it generates, right? Like the so you need the distance up to the next one, and you need how thick. There, it's too thick. It's too tall in each direction. Oh, it would actually generate that. So a different way to build this would be we make stairs like this, and we also make an erase stairs. And then we build this. And if we use an erase version of that and shift it down to then that would create the same stairs that we wanted, and it would let us create those solid stairs if we wanted the solid stairs. Now the only drawback of this is that it's going to be inefficient in terms of drawing a lot more texture data, because it has to, anytime you do this CSG with really big solid blobs, not just with thin slabs, it's kind of inefficient. But I'm not thrilled with the idea of stealing bits. We could steal bits from xlen. And then if you need really tall stairs, you have to instantiate multiple multiple copies. I kind of like the CSG subtract one. Just because it lets you do both kinds of stairs, and because it's kind of fun. Because still, the bottom two bits of Z-line, then you don't have to do multiple of them, but it does fail to align if it's not a multiple of 4. Yeah, I guess we'll steal bits. So this goes 1 to 4 thick. I don't think we ever need more than 2 thick. So if we're stealing bits, let's only steal 1 bit. If we're only stealing 1 bit, are we sure we can't squeeze this in somehow? Let's check the math. 21, 24, 29, 30, 32. Yeah. I mean, we're never going to make stairs that are 255 wide. So really stealing the bit from X line and Y line makes more sense. Let's just do that. All right. So, since util is shared, let's put this set of pound defines into util, even though it doesn't really belong in util. So util is now just shared. You know, and the packing things early could be bad because we don't know. Like, there's a lot of times in development where you're like, I don't know how this is really going to work. Maybe I need to add a feature later, and I need another 8 bits, and so I just expand the whole thing by another 32 bits. Like, I could just expand this by 32 bits, right? I could just put the extra data in another 32-bit thing. And so packing it now, if it turns out I need to add something else later, you know, could be questionable. In fact, now that I say that, there's kind of an interesting thing there, which is that you could put a pattern into you could make the bit pattern of an extra 32-bit word used as the pattern for which things to strike. So, like, this this thing here is like a 11000011, and use that pattern, which could allow you to do something more interesting, although I don't know what it would be, because it would have to always be growing by one, offset by one. But anyway, and so it may be premature to pack it if you're going to end up needing to add stuff to it anyway. So in fact, now that we've said that, I think actually let's just let that stay fixed. Leave those 7 bits unused. Put 5. Yeah, let's do that. And so then we have 8 spacing, 8 thickness, 2 orientation, 1 solid. No, I don't think we can do that. So now that you brought it up, I'm going to unpack it, just because it makes the rest of the code consistent, and that will be better for for processing efficiently, because they all use the exact same, they all do the math exactly the same. So like the color doesn't need to do anything different because it's already doing the logic correctly here. Oh yeah, we can do, there's a thing we can do here too now, to go back to variable width things, because we're currently fixed width anyway, so we'd be wasting that storage. This doesn't use it. Yeah, okay, it's just this one. So if we're stairs, so before we clamp the Z's, we did Z min. Oh, right, because we're split into the Z's. Yeah, yeah. We have to say int Z off equals Z base equals Z0. So that's where the pattern starts. And we want to unpack the things, probably. What order did I originally define it in? Spacing thickness. Yeah, that makes more logical sense. Actually, let's put orientation first. Now, of course, this uses a bunch of extra registers. It's going to cost performance for everybody. So it might be better to reconstruct these on the fly. So we need to compute an insert value. Insert so the pattern is we should compute it outside the loop. We want to limit spacing to most 32 because of the 32-bit words, probably. You know what? We're going to do this. If command type equals command stairs, do one thing, else do the normal thing. This is just a little too complicated to do in line. So we'll do it in an inefficient way because stairs are a small fraction of what the voxels we're going to do, so it's okay if it's a little inefficient. And everybody is operating in parallel, so everybody's traversing the same code. So these branches are not we're not evaluating both sides of these branches. Each lane can compute its own update to Z base because each lane represents a column. So, which is stored in pos. Why is pos +1? Oh, right. So we can still do this. So int thick bits is bit field extract of 0. Let's just do it explicitly. It's 1U shift left thickness -1. And we move the base up as we move along orientation. Okay, right, which was, we wanted to figure this out. We want the absolute position, which is pause, before these subtracts. And then we need to know where the actual x0 and y0 are. So we want the raw pause minus x0 plus region.x. Why does that have a +1? Oh, for the same, it's the same offsetting of +1. Stairs delta x, stairs delta y. So this is how far the current lane is from the origin of the stairs. But we only need this depending on the orientation, and we want to use a different calculation. So if we branch, orientation is the same for everybody, so we can just do this. Stairs delta equals this. Then we do x1 x -1, and that's exclusive, so we subtract 1 to be inclusive. Oh, we have to worry about the second position. Oh, this was such a mess. So pause is, I think that was just debugging. That shouldn't be necessary because that totally screws up the math. So let's make sure we didn't break anything by what we just deleted. Oh, right, yeah, we put that into util, so now we don't need our own copy of it everywhere else. compute measure. Oh, we don't even use compute measure anymore. Oh, that's that one's still 2. We don't use this shader anymore. Build texture grid line 56. We don't use this one either. So round line 56. Type equals command stairs. Okay, so we haven't broken anything. Let's put the debugging Windows offset. Put those windows back to so that they're lined up again. Just because that's distracting me. Okay. Okay, so back to the stairs. Okay, so we have to use pause. And pause is now just +1 wonder what it computes at the border of the thing. Anyway, so instead of using this, because then we're subtracting out region, so we already did that. We already subtracted out region from we have a version of this, pause.x, that subtracts region. So, and it added 1. Okay, so it's just that. Hey, look, that's much more sane. x1 minus 1 minus pause.x. And now it's a lot more clear what we'll do for pause2. So that lets us say that our z base gets offset by that. So z base 2 is z base plus stairs delta 2. And then z base equals z base plus stairs delta. And then we're going to iterate for int I equals 0. Int offset equals 0. Offset is less than 64. Cannot save file in use by another application. Oh, it's just a weird momentary glitch. And I steps by spacing. And then these z bases can get offset by z min. So they can be less than 0. While z base less than 0 and z base 2 less than 0. Yeah, I think we just do this manually. We don't even compute thick bits. We just iterate over all of our bits. We'll just do this really slowly. Just do slowly and get it right. So we loop over our bits. Get our existing value, and then we say for int j equals 0, j less than 32. So we want to know for each bit, does stairs delta, no, the z base plus k times spacing. So the z position here is z0, no, z min z min. Oh, z0 and z1 are already offset by z min. So why is, well, first of all, we already did that clamp earlier. We already did the bit array clamp up here. Right, I see. Yeah, that's necessary for... Let's not do that offsetting yet. And do it here. Because the stairs needs to work with the absolute heights. I mean, this is always 0 to... Oh, right, I see. Normally, we are allowed to shrink how far it goes, but we're just going to always loop over both words because we're brute forcing this. Because we only run if it overlaps. So we don't need to do more fine-grained culling. So we iterate over the bits. Okay, so our actual Z position here is... Our actual Z position here is Z min plus I times 32 plus J. That's the Z position that we're at for this bit. And then its relative position equals Z minus Z base. And so its phase within the thing, this is going to be super slow, is rel mod spacing. And so then if phase is less than thickness, then we set the bit. I think. And then we have to do the same thing with the second one. Maybe. I forgot to delete this line. Oh, well, yeah, we're not calling it. Build texture grid. No, main. And we say put stairs. And stairs. That stuff came out of this one, so that'll be tech. And then we get int orientation, spacing, thickness. Ori, spacing, thickness. And let's put stairs. And then stairs hole, stairs. P equals put stairs. Base P, x minus 12, y minus 6, z base plus 1, x, oh, this should be minus 6, x minus 6, y plus, sure, we won't worry about getting it right yet, base plus floors times floor height. Orientation 0, spacing is floor height, and thickness is 2. We have the wrong number of parameters. X, Y, Z, X, Y, Z, 1, 2, 3, count. Oh, the texture. All right. Totally wrong. Although you can see a stripe pattern to it. Not sure why. We're not initializing the texture data at all. Why does this extend too high? I know why it extends too high. If z greater than equal not z0. Yeah, we still need the original z0s. Right, we're not using bit array index anymore. Wait, so we don't need these. Z0 and z is less than z1. If z is greater than equal to 0 and z is less than z1. Why was phase always below thickness? Spacing 6 bits starting at the second bit. Spacing. Okay. Nope, still wrong. Does it at least not go off the top of the building though? Yeah, it does. I drew nothing, so I think this is going negative. Z minus Z base. Z base is Z base is 0. Z0, right. Plus stairs delta should be relatively small. Makes no difference. Oh, interesting. The interior. Oh no, that's just because it's solid, so it suppresses it. Why does this not work? We're computing the distance from the lowest step at this in this column, and then if that distance equals 0, let's draw it. Nope. Why is that distance never 0? Okay, let's make sure this data is coming through correctly. Spacing equals, I don't know, 12. Thickness equals 4. Orientation equals 0. Aha. Okay, so this data isn't coming through correctly. Command list I plus 2. Data 0, 2, 2, 6, 8, 6. That seems right. Ori spacing thickness. Ori spacing thickness. Floor height is 12. Okay, let's put this thickness back to 2. That's, in theory, the values that are being passed in. No, it's still. So why is this data not coming through? I know why, because the color does need a little bit of code. I was saying it just automatically works, but in fact it needs this, or type equals command color. Not command color, command stairs. And that can be turned off, and this should all work now. Okay, good. Now it's buggy, but okay, so the orientation needs to be 3, I think. No, 1. No, 2. No, 1. I think the orientation wants to be 1, and it'll be climbing away from us. I think that's upwards is north, but it might be north. Upwards is south. No, okay, it's upwards is north. The thickness is not working. That's because we hard-coded it. Phase less than thickness. Okay, so it's all working except for that weird glitch at the bottom, which I'm pretty sure is due to the stuff going negative. Although the height isn't actually negative. Oh, it is. Yeah, it's due to it being negative. But why is adding spacing not doing the right thing? Oh wait, well let's just do rel plus spacing. Times 16. Times 32. Times 256. The modulus just subtracts that back out effectively. So any amount we add here is fine. Almost. Oh, it's just because it's too long. Like if I make the stairs, that's the correct behavior. If I just make the stairs go from like -8 to 8, and you can see that you see what the pattern here is. Right, it's just saying it only extends the right amount if we make this be exactly floor height. So this goes from negative floor height to 2. So floor height to 2. It's off by 1. And off by 1 at the bottom end as well, actually. Oh, in which case this doesn't need the -1. Okay, there you go. So then we make the stairs hole twice as big. So it goes from negative, let's say 20, and then we put in stairs in opposite alternating directions, and the second one starts on 1 floor taller, and this goes -12 to -16. This goes -18 to -12, and the spacing is twice as big. So now we have alternating stairs up like that. Or we could make the stairs double back. Let's do the more realistic thing. The stairs are offset by floor height over 2. And then they only need half the and then we have to add landings. In which case now these go from to Y might be a little landing here. How would you do this in a real building? Yeah, you actually put landings on both sides. So let's put this back to put it back this way. I don't know what you're asking, given that's what I'm doing. And so then we want to make this a little bit bigger. And then we want to put the landings in. So the landing goes from x minus 18 to y minus floor height over, it's just y minus 8 z. And it goes to x plus x minus 6, y minus 4 height over 4, z plus 1. And then the other side of the landing is from y plus 4 height over 4, y plus 8, and the z z2 to z2 plus 1. Yeah, this is going to be a strictly voxel thing. No weird block shapes or anything like that. It is rasterized, so you could do weird block shapes. So I guess I could change my mind. Let's give that a different texture, just so we can see it better. And then let's fix the texturing of the stairs. Oh, that's nice. I didn't even mean to do the little outline, but it's effective. I kind of want to put physics in so that I can actually walk up these stairs. So I can get the bird's eye view. But I think that makes sense. I think that works. So let's do one last thing, which is to put in some slabs, to put in walls. So we have we go from let's do the elevator, x minus x, y minus 6, z base plus 1. It's these numbers here. And this one goes to x minus 5, y minus y plus 6, z base plus floors times floor height. Back deck. And then we do this on at the other end of it, plus 5 plus 6. Elevator, shaft, walls. Let's check that. What do you mean by do I treat them as primitives? So there's the walls of our elevator shaft. It's deeper than it needs to be. Yeah, I mean, that's what the... Oh, well, I mean, so the primitives are... It's a hierarchy, right? So you start with voxels, then you have commands that can build some kind of collections of voxels. And then right now, these puts are individual commands that put a single one of those. But I could make a put blah that generates multiple commands under the hood. So whatever functions I create become the primitives for the next layer of thing. But then the city is made out of multiple buildings, so you could think of a building as a primitive for building a city. So I don't think it's exactly a meaningful question, other than the fundamental thing of, yes, the primitives that I have to work with are the commands. Like, okay, and then the walls in the opposite direction. Plus 6 minus 3 plus 3 plus 4 minus 6. Okay, so I think that'll fully do the elevator shaft. Maybe it should be a little bit wider. So that'd be 2 elevators. I mean, I don't need to tune this perfectly because we're going to make an actual generator at some point. But and the generator will be parameterized and stuff. Yeah, but there's no ability to put a single voxel. There's no command to put a single voxel. So now, actually, wouldn't normally the elevator shaft just be the exact same depth as the stairs? Because you don't want to have to route the interior around that stuff. So I think you would just make... I think you would make these go to the same depth. So this is what? Minus 8 plus 8. So then these need to go 8, 8, 7, 8, 7, 8, 8, 8. And then we can put the walls around the stairs as well. All right, let's fix the stairs texturing first. Let's check in first. There's no put single voxel, there's just put slab. I mean, you can use put slab to put a single voxel, but... if you tried to do that, it would be so inefficient as to be ineffective. So there is some sense in which the commands are by definition the primitives. From the CPU's perspective, they are the primitives. But there will be a command that lets you place a bunch of individual voxels, so it's a little weird. But clearly, the intent is that you construct the city primarily from slabs and stairs and CSG. But I stand by the fact that what primitive means is contextual. So since it's rasterized, I can put anything in. One thing is that even voxels don't have to go through this engine. I can just build a mesh that looks like it's voxels and place it. And I've been thinking about potentially doing that. How many bits are reserved? Yeah, there is room for more bits if we want more primitives, but my intent is that these are the basic primitives. There will be sparse. There's a primitive reserve for 3D model, and there's a planned sparse array of loose voxels. Copy face pair model is an idea that it just directly stuffs it into the mesh without doing any voxel processing. Sticks it into the voxel mesh. And similarly, you could just make meshes that look like voxels and place them in the world and have them use the same shaders and render consistently. And that's all like an intentional design option. Like maybe the meshing system is not very efficient, and so for furniture, we just place the furniture without worrying about it interacting with the meshing. However, that will result in more quads because it can't hide the quads the furniture would hide. So I'm probably not going to go in that direction, but it's possible. Do you ever reserve the bits for the decals? What decals? Did I have decals somewhere in here? No. Okay, so we want to fix the texturing because we just didn't even write it. There was a decal in there. There in the code or in the images, in the runtime rendering. I don't know what you mean. Don't know what decal you're talking about. We could just use type okay, this we could just fill in the texture for the whole thing. Again, inefficient, but I think that will work. Yep. I just don't remember talking about decals specifically. I have thought about decals, but I don't remember talking about them. I guess I don't know in what context I would have talked about decals. There's this recoloring stuff that we already looked at, that we were doing over the weekend. Is that what you were thinking of? This stuff? Probably not, because this is already working, so I don't need to reserve bids for it. All right, so the stairs are working, but they're very inefficient. But I think we'll just live with that because everything is inefficient right now anyway. So is it working over here too? Because this has a different ceiling spacing. Yeah. I think I really want to get physics. I don't know, like. So we want to put stair walls. and all these values should just be in variables so that I don't um, of course, this needs to be potentially rotated to put the right textures. On the right sides. Make sure that still works. Yeah, we need to handle the orientation, but we'll come back to that. is half height. This is x2. This is x1. This is x12. Y rather. Y12. Does it just go up to the ceiling? No, it should not. It should actually go up one floor less. And if we want roof access, that goes in a separate location. Plus one. And then here's the orientation. And we actually need to change the numbers if we rotate it, but for now we can just at least pass in ori plus 2. Spacing is floor height, thickness put in the landings, and the landings go from x0 to y0. This is x12. This is half height. This is x1, no 2, x2. What was this? You can code a simple interactive put remove block. A reply to. I know it was a while back. 0, 1, 1, 2. That was just me referencing it. And then this is just going to be x0, y0, x1 minus 1, x0. I recognize this pattern. x0, y0, 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 y1 minus 1. Well, yeah, but why would it make an interactive put remove block? Like I really wanted physics simply because I want to be able to move around that space and get a feel for how it feels to move around that space. Because otherwise, like if the stairs and landing are designed wrong for movement, then it's not useful, right? Like the map that we generate wants to be playable, so we want to test moving around it. But why would I also add the ability to put remove block? Assume you had some method of turning regular meshes into voxels, because you did those trees by hand, hurt my head. I bought those trees. This is x0 plus 1. x1. 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 y0 plus 1. y1. 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 Return P. interactive put remove blocks on. Right, but it's nothing to do with what I was actually working on. And in fact, people make this assumption. I talked about this. Let's bring that up. Nothing's SCB. I'm not interested in AI, generative AI, and I don't even want to think about it. Under docs, maybe? Yeah. So if we go to here, here, when you have a world made of voxels blocks, there are a few things become incredibly easy to do that would otherwise be hard. Procedural generation becomes easier. That's how we're using it. Another is that destructible environments, or the average user can build stuff. But you don't have to do that. Like, people tend to do that once they make a voxel world. They're like, let's have the players be able to create and destroy blocks. But that's not part of the voxel premise. There's no requirement that people be able to place and remove blocks. And it's never been my intention with this engine that people be able to place and remove blocks. If you did, you have to remesh everything, which is annoying. You can remesh everything, and that's, we've talked about the performance of the remeshing. But the assumption that you must do that in this kind of engine is a mistake. If you look at the Voxel game dev Reddit, it's filled with people making Minecraft clones, which is just silly. Floor height. Oh, orientation. Oh, and thickness. Right? Did I pass in thickness? Yeah. And in this particular case, it's crazy because I'm trying to do procedural generation. And so adding interactive block placement is just nothing to do with it. Okay. So there's the elevator shaft. Why are the walls not in the right place? I screwed up the elevator shaft wall somehow. What? Didn't I test this? I thought I tested it. X0 to X0 doesn't work. I did not test it. Okay, that's all correct. Then the stair walls have the same bug, maybe? These should all be Y0s, these should all be X0s, X1s, Y1s. Alright, let's not put in the elevator shafts because that's confusing. Y minus 8 to Y plus 8. And then the walls. Y0 to Y1, Y0 to Y1, Y0 to Y0 plus 1, Y1 minus 1 to Y1, X0 to X0 plus 1, X1 minus 1 to X1, X0 to X1, X0 to X1. Those all seem right. Let's just do the walls in different colors. So we can see. Oh, it's because I'm using X1 instead of X2. I forgot I'd switched notation. Okay. It's a cool use case, sure, but if you make 100 voxel games, do all 100 voxel games have to have dynamic terrain and user-placed blocks? Like, why are there not 50 games with that and 50 games that don't do that? Okay, and then we need to put in holes for the doors. Door is 3 feet wide, 4 feet wide, 3 feet wide. You don't have to actually match the real one scale perfectly. Y0 plus 1, and it's 7 foot tall. And then we need a middle slab that goes from X1, Y12 to X1 plus 1, Y12 and Y01. So now there's that center wall. Okay, and then we need to go into 40-meter world, main, Z, copy that. And now if we press Z, Control Z, Control Z. Should the door be in front of the upstairs or the downstairs or in between them? Should those stairs be reversed, maybe? Why are the stairs totally wrong in that building? remove this from the beginning of the file, put it at the end of the file. So create building, make stairs, floor is floor height, y minus 8, y plus 8. So why does that fail in this one? Oh, it's not failing. Why did it look like it was failing? Oh, because it fails on this side. Because the stairs aren't getting built on one of those two sides. There's stairs there, but not stairs there. All right, let's disable the walls so we can look at the. No, it is working correctly. Oh, maybe we're hitting the command limit or something. Because there's a lot of commands in this small area. Or maybe there's a bug, just a logic error. So yeah, all the landings are there. One of the walls has disappeared. Let's see. Let me clean up. I'll be right back. So as a quick hack, let's just make things bigger. So now that'll be 512, which might be too much. Maybe it's a called commands. that? Called command lists. Where's the spacing for those specified? That's just hard-coded, I think. Oh no, it's called command spacing. The build texture grid should have that too. Where's textures full grid made? Textures full grid. Here's just textures full grid. Nope. Don't know. Do not know what's going wrong here. All right, let's make the building less tall. Where is building made? Here. Let's make it 15 stories instead of 95 stories. Okay, yeah, now it does work. I think it should line up with the down staircase, actually. The doors. So it's got to be a count, some kind of count limit. If we generate too much stuff in that one area when we do 95 stories. So let's make it big enough that it triggers. That's funny. If we hadn't made it set that big, it wouldn't have triggered. There it goes. Flaking out. But only partly. Just beginning to flake out. Okay. So there's a few things I want to do here. One thing I want to do is I want to go back to variable length data. And we turned that off because the atomic add stuff wasn't working with it. But what I was thinking is we can make everything indirect. So currently the command buffer command list stores an array of indices into the thing. I'll see how big count has gotten at this point. 4,600. It's right now the limit is 16,000, so we might need to bump that up too. So currently we use this indirection right here to find the start of the command list, of the start of each command. And what we could do is make the culled commands also, instead of outputting like this, we could output I. Wait, before we do that, let me check in. I think I checked in recently, but I'm going to do it again just to be on the safe side. And if we make the culled command list also indirect, that will save memory. It probably will not be any slower. It might even be faster. Because the commands will stay in cache. And now we need these now need access to both arrays. And we actually already have it, raw command lists. I don't know why. Probably I was debugging something. So now off equals command list I plus plus data. Let's do this. And we don't need to increment I because we're reloading I every time. And then we need to do that for build texture grid. Oh, sorry. And then let's change this name to command list. And this is culled command list. So num comes from that. The indirection is for that, but the data is from command list. And then we go to build texture grid. Texture grid is at 5. Command lists are 1 and 2. These are at 5. Command lists are 1 and 2. Culled. Yeah, okay. So now we want a similar thing here. We say off plus. I guess that could be wait. And now we don't need to increment I because we reload it every time. These are dead. List. There's no way that works. Okay, the geometry is right, but the texture grid is wrong. Why do I get that pattern? I remember authoring that pattern explicitly. But why does that why do I get it by default? Seems weird. X plus Y plus Z. You get that pattern by doing X plus Y plus Z. I don't know. I don't know where that's coming from. Anyway, so clearly build texture grid is wrong. Yeah, this needs to be cold command list. Cold command list. Okay, it looks like we're back to where we were. And this is still broken. With Z fighting or something. Why would it Z fight if I'm not moving the camera? Shouldn't it be stable? I guess that's actually a race because we're remeshing every frame. Yeah, it's actually, if I turn on and off the remesher, it's failing in different ways. So now that we're using called command lists, called command spacing, we can change called command spacing because the number of called commands, this is no longer the storage for them, it's the number of them. So we can say in any given column you have at most 2,000. Let's say 4,000 just to be on the safe side. Since given the problems that we're having, 4,000. Okay, and then where we allocate the called command, we now only need 32 times 32 times 4,000 entries. Each one is 4 bytes, and there are 2 sets of command lists. So that is now 1,000 times 4,000 times 4, or 16 megabytes. This is gone. So I wanted to see how much texture memory we're allocating here. Oh, here's where I do the, this is me filling in the textures full grid with the debug data. has update. Which update I find? Our main command list. We have room for, let's say, 32,768 total commands. And then each command is at most 32,768. I mean, there's each of those commands is at most 4 D words. So this is now, that's 8 times 65536. So it's under, it's less than 1 megabyte. Split job storage. This is, jobs are occupancy, visibility D words. So there's a fixed number of them. We allocate way more. Split job spacing. Did I already bump this up once? I think I did. So this is the number of D words to process in a single 8x8 column. And but of different density types, and we are getting a mix of densities now. But still, the total number of D words is only 32 times 8 times 8, right? 64 times 32. Yeah, 2048 should be the max that you could have. So that shouldn't be being exceeded. Occupancy should use it, texture grid should use it, and color should use it. There it is, gold. Oh, yeah. What could be going wrong? It does look like it's just one particular 8x8 column that's failing. Right, like it's lost the bottom data. Like maybe it's getting overwritten by this column's data or something like that. So that its first commands are missing. So debug data of These numbers are really big. Is that somebody else writing to that? Not the color? Somebody else might be doing debug data. Yeah, it is somebody else writing it. Okay. Oh, right. We were debugging how many voxels were involved. Nope, still. Aha. Oh, that was texture data. That makes sense. All right. So we're going up to 290 here. So this is probably the elevator shaft or the stair shaft in one or the other building. This is probably windows. It's 95 stories of, so you'd have 95 windows. If two windows overlapped a particular 8x8 region, then you'd have 190, and then you have you should have all the floors overlap. Oh yeah, so it could be 95 windows, 95 floors, and then a wall and something else, and the wall and the roof would be 192. So these have even more going on. The stairs are only one big command for the whole thing, so it has to be the landings. The landings and the floors overlap. So it gets up to 290. How does that then run out of something? Because we can afford way more than 290 commands. Nothing is limited to 290 commands. So which thing is going wrong? Build texture grid is just absolute space. So occupancy, we're losing our stairs. But the stairs is just one command. So it could be voxel jobs. Maybe it's too many voxel jobs in one column. Okay, certainly 16,384, which is 2 to the 14. So if we look at log 2, it's 14, 5, and 5. So 5, 5, 10. 14 is 24. 25, 26. So it's currently at 64 megabytes. So let's pump that up to 128. voxel job spacing. Let's see if that's an issue. Yep, that was it. So we just actually had too many visible voxels to process in one 8x8 column. There were more than 16,000. Which it makes sense because 8x8 is 64 and it's 1,000 units tall. So worst case, you know, you have one visible on every 4th level. So that would be 64 times 256, which is 16 times 1K, so 1634. So yeah, so let's push that up to 4 to handle the extreme cases. Most of the time you shouldn't have that many. But stairs is definitely one that creates a pretty crazy thing. So now this is 256. All right. So now we can go back. Okay, so that's all reasonable. Go check it in. All right, so we have we'll just right if it's a zombie apocalypse, we don't have doors. If we need doors that they need to swing open, so they can't use the mesh system anyway. So just having open doorways is the right thing. We should draw elevator doors as textures, but we don't have real textures yet, so I don't want to tune the texturing at all. So what do we do now? We need to deal with the orientation. The building needs to be able to face in any direction, so we need the stairs to work correctly rotated. I think what we do is we start making more tiles. So we currently have almost 2 million quads. Let's assume that most quads we can get is 4 million quads. You know, chunk. 4 million quads. Each one takes 3 UVEC 3s. I mean, it's 1 UVEC 3. So 12 bytes. 12 bytes times 4 million is 48 megabytes. That's a pretty big thing. 48 megabytes, 10 chunks is 480 megabytes. This is a 6 gigabyte GPU. So the thing is, it won't actually be that big in practice. How do we want to deal with that? I think what we do is we'll copy it. OpenGL copy shader storage buffer. Oh, well, yeah, it is a shader storage buffer. Copy buffer subdata. So we can use this. So we'll have this vbuff be our build buffer, and then we'll copy it into another buffer. What are we doing for index buffer? Do we just have a fixed index buffer because that's, yeah. We just have a hard-coded 32 million indices. Isn't that too small? 32 million indices is 8 million quads. Yeah. So yeah, we just reuse that for everything. So okay, so we use this as our what's called our build vbuff. I'll be right back. I remember talking about this. I need x and y to actually be able to be negative. X0 and xy. Oh, that was why they said 9-7. Yeah, I need to actually change to that format so that these can go negative. So that buildings can cross chunk boundaries. So they need to be able, their origin needs to be the origin needs to be able to be off the edge. So the build vbuffer, 4 million quads times 12, we said it was 48. So let's put that down to 64 megabytes. Because we're using a lot of storage. There's also all these. Look at that, 64 megabytes times 6. We're using so much of the memory in this thing. This is 384, this is 256. So this is like 600 megabytes maybe. And this is like 800 megabytes. $768, 900 megabytes. So this is maybe using 1.5 gigabytes combined. Our frame buffer isn't that big though, so maybe that's fine. Like, can we then add another like Like, what happens if we try to create a 2 gigabyte shader storage buffer? Will that actually get allocated? Oh, yeah. You did create it without error. All right. So let's make it 1.5 gigabytes. So now so then we'll sub-allocate from that one for the storage for each chunk. Which lets us be more flexible than if we allocated a bunch of separate vertex buffers. Although maybe just for simplicity. Sure, for simplicity, if each one is limited to let's say 2 gigabytes, not 2 gigabytes, 2 megabytes. If each one was limited to 2 megabytes, not 2 megabytes, 2 mega quads, 2 million face pairs, then each one would be 24 megabytes. So let's say we had a bunch that were 32, so we could have vbuff, so that, say 50 of them. So that we can only have 50 for now. Until we sort this out, we can only have 50 loaded at once, which is pretty small because it's 50 around you, which is what, 7 by 7? So that's only 3 by 3, a 3 by 3 grid around you. Vbuff. So that's 24 megabytes. 24 megabytes times 58 equals 1200 megabytes. Vbuff I minus 1. Okay. Claim to have worked. Let's see if we can trigger an error from allocating too much. So if we make each one of these 128 or 256 megabytes, we should run out. So I want to see if I get an error from it. I probably don't. Yeah, the vbuff I minus 1 will always be valid. The thing is that it shouldn't actually be able to create storage for it. It should be getting a failure. Oh, I may have disabled error checking. Nope. Okay, well, clearly these can't actually be being backed by memory, right? 50 times 256 megabytes is 100 times 256 megabytes. It's 2.5. It's 25 gigabytes, right? There's no way that can be valid. So it's just not failing. Like we create it. GeoBuffer storage. There's just no way that can actually be backed. But since we're not putting a data in it, maybe it's lazily deciding if it's available. I mean, I think it should give me that. I guess what we should do is store something in it. Update buffer, vbuff of I, 0 for data. There we go. Now it fails. Unknown internal debug message. Oh, great. NVIDIA OpenGL driver has encountered an out of memory error. Okay. But that's actually not out of GPU memory, potentially. That might have been out of main memory. But now, if we allocate so it was 2 million. Let's make it 3 million quads. 36. Now, if we did 100 of those, that would be 3,600 megabytes. So we'll do 50 and see if we can run that without error. Yes, we can. Can we do 100 of them? Yes, we can. Can we make it 6 million quads? Yeah, now it fails. Okay. So we are right at the limit. And if we need to allocate more memory, we got to store textures and other stuff. So this is going to be too big. Okay. So let's bring this down to 3 million quads, 2.5 million quads. So 2.5 is 5 times 6. So it's 30. Let's just say 32. 32 megabytes. Okay. Now, if we don't initialize it, that's still about the same start time. Why have our times come down? Remember, meshing was over a second? Maybe because I made the command list indirect? Oh, so now that the command lists are indirect, the called command lists are indirect, we can go back to variable-sized meshes. These were variable sized, right? We were just outputting, the color was outputting fixed size. Oh, yeah, so there's nothing to do because we don't use the lengths anywhere because it's indirect. Okay, so yeah, maybe that's why it's back to being fast. I mean, fast enough. Not still slow. Still spending way too much time. But okay. Now we have 100 V-buffs. So we can have 10 by 10 chunks around the viewer. Still isn't that great, but enough. And obviously on a higher end hardware, we'll push that out. It's just all hard-coded for now. So yeah, this needs to get split into multiple files soon. So let's do type def struct chunk. We have our int x origin, int y origin, int vbuff, index. We'll index into our vbuffs. And no, I guess we'll just take ownership. We'll just take ownership. We'll int vbuff. And then we need to know how many indices to draw, and I think we're currently writing that into, yeah, we're writing that into one of these. That is in the buffer mesh count. Okay, so we're currently creating a 64K buffer. So we could say that like it stores 256 meshes, each one is 256 apart. Int slot. So this is slot times 256. And that's going to be mesh from Voxel job that index into mesh data. Uniform int which mesh index into mesh data. Index offset. Yeah, okay. Right, because that it's intentionally shifted by, so it's in measured counting indices. That's the weird hack. Okay, so that's just index offset, which is measured in D words. And that's in the mesher. What is it called? Index offset. And the variable was slot. Slot times 56. So This is currently limited to at most 256 chunks at a time, which I think is plenty. I mean, it's only 16 chunks, 16 by 16, which is only 8 deep. 8 deep is 8 times 256, is only 4,000 feet. So it's only about a mile, ballpark, which is pretty small. I'm used to doing much larger scale stuff, but because these are only foot wide voxels, oh, sorry. So way back, I was starting to say, so the whole idea of like half height blocks and stuff like that Minecraft can do. This part of the engine won't ever do anything like that, but you can just make meshes. Since this is just building meshes, you can just make meshes that look like voxel data, that looks like voxel shapes, and then run them with the same shader to get the same look. And so you could make meshes some other method, like on the CPU, that includes half-height blocks and stuff like that. So if you really want, if there was some reason to do it, we could do it and still leave all of this alone, operating purely on voxel scale, and only use that. So for example, here's an example. Maybe you want to have wires. Maybe you want to have, telephone cables or power lines, and they look bad if they're full voxel thick. So you could draw them skinnier by just drawing them, voxelize them, draw them as blocky, but at a smaller scale. Or slope blocks or half height blocks. So we have a VBuff and we have a mesh slot. And then we have GL copy. What was this? Copy buffer subdata. What is named get issues? Not till 4.5, and we're currently on 4.4. So we use those. Let's just copy the full size of it. Which is 32 megs. And we want to copy from build VBuff. It's 64K. Right, okay, so 256, yeah. So that comes from C arrow VBuff. but this is measured in units, so it's 64. So we have max chunks of, it's also 100. And then void chunk I like chunk, maybe. Just trying to get something working. We don't really care. If chunk of I dot allocated is false, chunk of I dot allocated equals true. Chunk of I dot x equals x. Chunk of I dot y equals y. I guess that should just be in the caller. Numb buff, I think. Yeah. personal? Is that what it is? Yeah. All right. Let's try allocating multiple chunks. Chunk asterisk C. C equals alloc chunk. If C is not equal no. Chunks num chunk plus equals C. Num chunk times 256. You knew 8 hours of focused programming. I've only been programming. Oh, maybe you've been doing 8 hours of focused programming. I've only at 3 hours. So build voxel chunk of C, and then when we render, how do we don't get to specify an offset into that? Or maybe that's what that is. I guess this was always 0 anyway. So that's C X origin, C arrow Y origin. Okay, I surely have missed something here, but let's limit us to only making like 8 of them because our rendering is too slow. Chunk. If num chunk less than 10, we make one. And x equals num chunk mod 4. All right. Now, of course, they're all making the exact same chunk right now. So let's mix that up. Build map. It goes into make chunk. Build voxel chunk and go into make chunk. Build map. We need a random seed, but we'll just do, you know, something. Flat noise strong. Flat noise strong. Noise 32. X, Y. And then what we'll do is we'll put the 2 buildings in the same place for now, but we'll make the number of the number of stories come from the seed. Int floors, floor height. Floors equals 8, floor height equals 12. And so now this will come from let's keep it even for now. Do we use X? No, that was old code. We didn't put floors and floor heights into the right spot here. Five, 12, 6, 10. 5, 12, 6, 10. So they're all the same. So flat noise is not the noise function I want to use. I thought it was. Or I'm not passing in different origins to flat noise strong. No, it must be because they're positioned separately. Like they're both scaled up by 256, but it's messing with them enough that the scaling up by 256 shouldn't matter. I mean, do that. Am I still putting them into the wrong spot? Floor is floor height. It sure seems like seed is the same no matter what. Seed XY. No, seed is different every time. But somehow it's computing the same floors and floor height. What? How is that possible? We are passing floors and floor height in. Oh, we're not resetting the command data to the start every time, probably. No, we are. Command data. Something isn't getting zeroed, probably. Commandless color, does it zero at the beginning? Yeah. What? Okay, there's two possibilities. One is that we're not. One is that the seed calculation isn't working. The other is that we're not actually getting updated map data every time. Or that we're not updating the mesh. We're not rebuilding the mesh correctly every time, and we're getting old meshes. When we render, are we making sure that we render different meshes every time? Did we get that? We do the... No, we don't. 256 times 0 mesh slot. Let's check what that actually is supposed to be. GL draw elements indirect. Specifies a byte offset into the buffer boundary GL draw indirect buffer. Yeah, okay, that is what it is. I just have to cast a 10 void star because of the buffer craziness. Nope, they're still all the same. Why are they still all the same? What if we just say 1024? Am I not updating mesh slot? Yeah, I'm not. I need to actually allocate mesh slots. We could just have them be strictly parallel. We could have a VBuff and a corresponding mesh slot and simplify this a bunch. Okay, what's the error? Indirect must be a multiple of 4. Aren't we multiplying this by... Oh, we're not multiplying it. Byte offset. Okay, still busted, and busted worse with this weirdness. I think it's getting the wrong VBuff. I didn't ever do this. Where do we set the VBuff? Okay, they're all different now. Hooray. For some reason, some of them, the shaft went all the way up to the roof. Is this one? This is missing a wall. So we do still have some bugs with the build, because this is missing its wall. Unless it's not a bug with the build, it's a bug in the logic of where to put the wall, and it put it somewhere that got erased. But that seems like a pretty good place to stop, I think. I mean, maybe not. Maybe I should just take like a half-hour break and then continue. Yeah, let's have that be a stopping point for a break. Is it better to stop the stream and restart it, or should I just leave it on for 30 minutes while I take a break? VOD-wise, better to keep it on. I mean, I can upload two videos. It's not the end of the world, but yeah, that's a good point. Is if I don't stop and, well, yeah. Like, I just don't know if it's bad form on Twitch to leave the stream up while you're not actually there. I assume that you're not supposed to do that. Yeah, I would put a timer on screen if I did it. In fact, I would probably stop the stream, restart it with the countdown timer, and then stop that stream and restart it again, so that way I can upload 2 parts to YouTube without the countdown. You lose viewers generally. Twitch doesn't care. Okay, that's good to know. because I don't mind losing the viewers. The goal is to keep viewers who know I'm coming back, as opposed to if I just stop the stream and then the viewers don't ever come back. Can you not download the broadcasts? I don't know. Like, I'm not sure what that has to do with it. The least friction is uploading to YouTube by restarting the stream so that I don't have to manually cut out the countdown part. But I mean, I could just leave the dead time in the YouTube stream too. It's not the end of the world. Yeah, I don't want to have to edit out the part. That's tedious because then you have to either recompress it or do terrible shenanigans with FFmpeg to cut it out without recompressing. But also, I upload to YouTube at a higher resolution than I stream to Twitch, so I don't want to download it from Twitch in the first place. Yeah, tell you what we'll do. We'll take a break and I'll stay on stream and we'll switch to Facecam and we can chat and I can surf the web and you can't see me surfing the web. I don't think FFmpeg needs you to recompress if you split vids. Yeah, so that's what I'm saying. If I have to edit it in a video program, then I have to recompress it. If I don't do it in a video program and I have to use FFmpeg, I have to manually figure out where the cut points are and rejoin, and it's a pain in the ass I don't want to do. That's why I just stop and restart the stream every time normally, so that it's just automatically split already out of OBS, and I can just upload it as it is. But what we'll do is we'll just take the break in chat. We'll stay in chat, and I can answer questions. We can chat about stuff, and we'll just let it all go onto YouTube. As I, meanwhile, check my social media and check my email. I got a good off topic. Have you seen the new Pokemon or Dragon Quest builders? Looks like Voxel Tech done right. I have not seen them. I don't even pay, like, Pokemon post dates my gaming like I was out of anything except PC gaming by the time Pokemon came out. And I don't really generally follow modern voxel technologies. Do people remember Jason Lin? He had these amazing looking demos. The last game I played is Balatro or Rocket League. I have a whole queue of stuff that I need now that I quit Epic. I have a whole queue of stuff I need to start getting, but I haven't spent any money yet. Haven't spent any money. Haven't bought any games yet. I need to actually like buy blueprints and some other stuff. I think it's John Lane. YouTube. I've had these amazing looking voxel demos. And you can see these wavy voxel, these wavy things. If you look closely, they're getting voxelized. Like they move when they move. They're not moving voxels. They're moving through the voxel space and getting revoxelized, sort of. So it's just incredibly high resolution, and everything's animated. It's just crazy. But then he disappeared. Like no idea what he was doing for the tech. I poked around on Reddit, and there was somebody who's like, "Oh, he's just doing the most obvious, simple thing. There's nothing magic going on. It's trivial." And then nobody else who knew. And so neither of those was a useful answer. I don't believe the guy who claimed he knew what he was doing, and that was a simple, trivial thing. And then there was somebody, I don't know if it looked a lot like his stuff, but it was like an interior space. But it wasn't this one. So I don't know if it was a different author or if it was one of these videos. This is all water. Like, it was like a temple or something. Why is this? Oh yeah, it was this. And I just I have no idea what he was doing here technologically, and maybe he's drawing the voxels as little squares rather than as little cubes, because some of the stuff kind of seems that way. Some of this stuff, well, those look like cubes. So I really don't know what he was doing here because his voxels are so small. But he just disappeared. He stopped updating. This is the newest video is like 4 years old. Which then makes you wonder, well, wait, could this tech really do what it seemed to be doing, or was it a little smoke and mirrorsy? This one is that. Let's add a new source text. How do I change the guy? There's change guy. All right, sorry. Prefix with nothing stew if you want to make sure I see it, because people have been saying stuff and I I just don't want somebody who wanders into the stream and sees this up there and thinks this is what I'm working on. I don't want them to be disappointed. Don't want them to be disappointed. Don't want them to sit here for through the chat, and then when we get back to it and I start doing the city, and they're like, that's not cool at all. But somebody mentioned that, like, yeah, where the actual game is using this stuff, and this is a thing you see in a lot of game adjacent areas. I've seen it with text adventures too, which is that you get technologists who enjoy making the technology, but they're not any good at making the games, and I'm one of those people. Oh yeah, of course the city is cool, just different expectations. Um, so yeah, I think you get a lot of, if you go into the Voxel game dev on Reddit, like I said, all these people who are making Minecraft clones, and then you get people who are not making Minecraft clones, but they're technologists, and it's not clear how many of them have any good game ideas, or even in the end are going to be able to make a game or even care about making a game. Now, I've certainly made games, so I'm interested in turning things into games, but I may not. I may just do the tech and never get to the game. So again, prefix with nothing's true to make sure I see it. If you have a question or whatever, you can chat amongst yourselves. It's fine. Obviously, that's the whole reason to do the prefix. Another thing we can chat about is, what should I be doing? Should I uh, work on making buildings better? I'm a little limited because I need to. I've been trying to collect textures to get something closer to a final texture set that we can use. Um, but that's not ready to go, so I can't. Yeah, if I had any idea how he was doing this, I might try to pursue it, but I have no idea how he's doing it. The old voxel compute shader that mysteriously got slow was kind of imagined as doing this, like being able to do really small voxels. Um, you could do this scale and small voxels. I was using it on a much larger scale and larger voxels. Um, um, or I can start working on the large scale procedural generation, which is building the basically you build the roads, and the roads determine where the there's some technical term from urban planning or city zoning or something for the area between the roads. So it's a chunk of land that you then divide into lots normally, and then the people own the lots, and then you put a building on each lot. And so you start by making roads, and then the roads determine where those blocks of land are, which are not necessarily rectangles. And then you divvy up the land uh, to put the buildings on. So it could start, and so in the real procedural generation, you have to go in that order. You have to generate the roads to know where the buildings are going to go. So I could start working on that part of the procedural generation, start working on the road layout. We need ground, so you could start putting in a ground layer, which would probably be a height field. Um, Probably it would just be the first command, and using up one of the 8 command list types for a thing that is only going to be used once, which probably doesn't make sense. So probably we just hard code in a first special step that just processes a height field. Because the terrain is not going to be very detailed, but if we look at ZMC1, wait for the slow startup. This is mine. Um, So you can see how the road network is done. But anyway, if we look at this, you can see that the ground slopes very gently. And that's all I want for the new one as well, is mostly slow, gentle sloping. Maybe we can put in rivers and the river banks will be steeper, but for the most part, it's just this kind of slow, gentle sloping. And so doing that with a height field is probably just fine. Like here, I actually have some weird discontinuous height. I don't know why. I'm not sure what's going on with that. Probably the buildings force a height under them, and then it's discontinuous. Yeah, here's a place where it's actually a steep slope. But anyway, I think a height field is fine for that. So I could do a height field ground. I could work on the road network, procedural road network on a large scale. I can work on improved building generation with the caveat that we don't have real textures. What else did I do today? Multiple chunks of stairs. Inefficient stair generator. We need to go back and actually optimize that. The stair generator. If we restricted it to 16, the spacing of 16, we can make it really fast, but okay, nobody had any opinion on that. That's fine. It's my thing, not yours. So yeah, let me talk a little bit about some of, just to kill time here. Maybe I'll do a whiteboard talk about how the stuff works. That might be nice. I've talked about it in a previous thing about how we make a seamless infinite city. Because I poked through the Reddit Voxel game dev, and there was a post to a YouTube video that somebody had of making an infinite mega structures, just meaning, city-ish. But when I watched the video, he didn't seem to actually. It didn't really seem to be infinite. He seemed to have, if I understood it correctly, it was not 100% clear. He used wavefront collapse to make a big texture, and then use the texture as the floor plan for the infinite city, which I assume means he used that infinite texture repeating. He kept saying he used it as a substitute for Berlin noise. But then that if he's using a repeating texture to generate the floor plan, then the infinite city is repeating. So I shouldn't be surprised. I'm not I'm not saying that the guy's effort was worthless or something like that, but I can't at my level of skill, I can't expect to actually be finding people on Reddit doing something that's actually more sophisticated than what I'm doing, with the exception of John Lynn. Let's just leave this playing. Oh yeah, one of the things you can see is he's clearly doing some kind of ray tracing because he has reflective and refractive stuff. So probably the whole engine is ray tracing. And that was sort of what the see that see like some things look like cubes, but some things just look like flat squares pointed towards the camera. Like this, all this stuff in this grass, the stuff, especially. But those are clear cubes. But like that stuff just kind of looks. I guess it's just that they're cubes, but they're that you happen to be axis aligned looking at them. Yes, feel free to post links to on topic stuff. Yeah, where did he get this data from? Is it all just meshes converted from meshes or something? It's crazy. That because that's another thing that you really to show off something like this well, you really want good data, and he excelled at getting good data. John Lynn already burned out on it. He went silent 3 or 4 years ago. Yeah, this one's from 6 years ago, and the new engine with even smaller voxels was from like 4 years ago. Yeah, it has a pretty similar look with the really wobbly dynamic stuff. Like I've never done anything with the voxels this dynamic because you have to re-voxelize or something. I don't really understand how you do that. I guess you could just resample if you stored it in a 3D texture and just offset within the 3D texture. So you're always you entered your sample but you're sampling from a distorted 3D texture. I guess you could do something. I mean, it looks crazy exaggerated, and which is kind of a real problem probably because you can't move by smaller than a voxel. So you either don't move or you move by this large amount. Although the newer engine from John Lynn had the voxels were so small that that was acceptable. Like he could have relatively fine movement. Like one thing is, it's really easy to quote unquote cheat and just use a different method to draw some of them. Um, Not saying that's how they're doing it here. Maybe it is all just like ray traced. It's all sparse voxel octree ray traced, and it just you can do that fast enough. Maybe this stuff is being fat bitted too. Like maybe it's rendering at a relatively lower resolution and being upscaled. I don't know. The Shadow Glass engine, not Voxel with 3D pixels. Yeah, I saw a little bit of that stuff. What? Oh, I just wanted to look at the image. Oh, he doesn't have a large scale version of it, so you can't really see the voxels here. This is just in input output, not actually rendering. It looks like. Yeah, no worries, no worries. Um, anyway, so you could easily do these particles just by rasterizing extra boxes and have them animate and have the rest of the world be static. That's how I would always expected to make stuff work. Um, I actually have another compute shader raycast engine for voxels where I had the idea that I might actually try implementing like 8 different ways of rendering voxels all combined into a single engine. Like some are meshes, they're being rasterized. Some are compute shader traced with several different possible compute, because there's like the method that's used for teardown, and then there's like the method that I used in my old demo. And so I was thinking of like this sort of weird trickery of different. So let me give you an example of the rasterization thing. Uh, I talked before about how like power lines, you might draw them differently at a different scale. But even if you were drawing everything at the same scale, you could do a thing where you like in my uh, you want space skipping, so you want really big open empty spaces. And if you run power lines through those empty spaces, you mess up the space skipping. And there's actually a similar thing in my compute shader engine. And so I did have the idea that, oh, well, like these elevated power lines, uh, draw them with rasterization so that the compute shader ray tracer doesn't have this very tiny amount of stuff interfering with the free open space, causing stuff to render slowly in that vicinity. So yeah, so I had this idea at a certain point of like just using like 8 different methods, mainly just to use 8 different methods, not because you actually need that many to achieve optimal thing. But it would just be kind of funny to have a whole bunch of different methods and then make a YouTube video showing it off and not explain that, and just be like, yes, look how amazing this thing is. And it's like, it's amazing because it's just doing totally different stuff everywhere throughout. Like the moving foliage, one way you could do that is remesh on the fly, but only a small amount of foliage gets remeshed, and then you instance it, and it would like probably look fine. It would look probably like all those demos do. Uh, but instead of having to move tons and tons of voxels, you're just moving a tiny number of them. So that would have been kind of a fun thing to do. But it didn't seem to serve much purpose except to make a trolling YouTube video that pretends that it's that you would write up and say, my new voxel engine, nobody's ever thought of this before. Credible look at all the different things you can do with it. It's like, no, you can do all those different things because they're all different methods. But that's a little too trolly. And heck, if I really wanted to troll at that point, then I would like use a 5090 to capture it, but have the 5090 display that it's running on a 980 Ti. Or at that point, if you really want to cheat, you capture it offline. Like you record the input and then play it back and capture it at a higher resolution that's not real time. If you really wanted to cheat. But it would be more appealing to actually be real time. Like that's cheaty. And my preference would be it really does run in real time. It's just that the feature set isn't as magic as it seems. Real time CSG is another thing that you can do, right? Where you're intersecting, and then you determine that you collide with a solid over this interval, and then you have a subtract, and you determine which intervals you collide with for the subtract, and you can subtract those intervals. And so you can have real-time CSG where stuff is moving through other stuff, and it's really convincing. But you would just isolate that. You would just like, oh, I have this one little area that uses the dynamic CSG, and it's traced in a totally different method than everything else that supports the dynamic CSG. But instead, I would just do this boring, meshed, rasterized procedural city as a more realistic and useful, practical kind of thing. Leave something running since I have the this is not mine up. But I think what we're going to do, since we just got multiple chunks working, is we'll finish up the multiple chunks so they're actually let you move around, build chunks corresponding to where you are, and then we should do Frustum culling. And then if we can do chunks that let you move around the world, then I think the thing to do is to do the larger scale world structure stuff, which is the road network. And I think we'll start that by doing a whiteboard talk explaining how all this works. How do you do infinite procedural city? I believe I've talked about it before on the whiteboard, but I want to do a little more in depth about some of the features and how we'll do it in this version. So I'm going to clean up, and then we will do that whiteboard talk. Actually, before we do the whiteboard talk, I'm going to order groceries. So that they get here today. Because if I wait too long, they'll Won't get here till tomorrow. I guess that will have to do. Oh, no, wait, there's one more thing. Out of stock. All right, there isn't one more thing. All right, so. Wait, I had one more thing to do. Okay. Let me check my mail real quick. Nothing. Check my social media real quick. Nope, no notifications. Okay. So, so in this style of procedural generation, where did all my other pens go? Did they fall in the trash? You've got to not put the trash can under the whiteboard. I don't know. I don't know where they went. There's some up here, but I don't think that's. Do I have black? I do have black. Okay. So there's a certain style of procedural generation, which I'm not sure what the official term for it is. One way to talk about it is random access, which is like Perlin noise. You just hand it some coordinates, and it gives you back a number. And Minecraft works this way. You can just ask for any chunk, and Minecraft can build that chunk without knowing anything about the rest of the world. Whereas a lot of, like, if you look at papers on city generation, they all work by saying, well, you start by putting down a road, and then you put other roads off those roads, and you put other roads off those roads, and you're planning out the whole city at once, so that the structures make sense. But what we want to do is the Minecraft style random access. We want to do an infinite city where you can just drop down anywhere in the city and have it make sense. So you can't do this sort of large scale planning. So you have to do something else. Um, so we'll talk about, and there are a bunch of strategies for this. People have written up stuff on it. I don't really remember the details too well. Um, there is some kind of multi-phase thing, which is similar to what I do, but I think there's a sort of more structured, intelligent way of doing it than what I'm doing. But I don't really remember what the details were for it. So another thing that you see is like a way that um, so so a thing that happened is Pixar used to use not regular textures. They used sort of virtual textures that were constructed in a shader with random access using like Perlin noise. And so one of the things that they would do is what they called bombing, which was basically putting on a decal, and you would divide the thing up into a grid, and in each grid square you would decide where the decal went. But the decal could extend off the edge of the grid, so you had to look at all the neighbors. So you would look at the immediate neighbors, and you'd be computing something that fell in a particular grid square, and you would look at 4 grid squares because you'd need the neighbors, or 9 or whatever. So there's different strategies like that too, but that's not how this was going to work exactly. So so we'll talk about so one of the things is that we're going to chunk on different levels, and it doesn't matter. So I'm going to maybe talk about chunks here in a sort of fictitious way that don't exactly correspond to chunks in the engine that we're going to make. But yeah. So the fundamental thing is that we have to make a chunk of the world. In this case, we're making 256 by 256 chunks. 256 by 256 by infinite tall. We only chunk in the XY plane. And so you can imagine that we have this big map, and this is a chunk. And here are some neighbor chunks. So this is 256 by 256 by whatever voxels. And what we populate this with needs to meet up with the neighboring chunks. So one way to do that is you sort of say, well, what does the neighboring chunk want to make? Well, what does this want to make? But that's like, well, you can't do that. Like, you can't, you're trying to make this chunk. So saying, let's look at what the neighboring chunk wants. But you can do this sort of phase thing where it's like, well, at step 1, this wants certain things, and this wants certain things, and this wants certain things, this wants certain things. And then at step 2, you combine them or whatever. And so when you're computing this, for step 2, you can look at the step 1 of the neighbors. That's a strategy that I've seen people talk about. But we're not going to do it that way. There will be a little bit of something like that, but it won't. It's not based on the neighbors. So what I talked about before is that you can think of these as a lot like Wang tiles, where Wang tiles are special tiles that you can plop down that create a single continuous grid. In math, they're known for being able to tile a plane without repetition. And in computer graphics, there's like, what's the smallest set of wing tiles you can make that allow you to tile a plane without repetition, or that you can't tile with repetition. You can only tile the plane non-repeatedly. But we don't do it that way in graphics. In graphics, we make a lot more wing tiles, and we just place them down to make sure that they match at the edges. So in the real wing tiles, you have colored edges, and you make sure that you constrain to place tiles next to each other only if they're the same colors. But for infinite procedural generation, rather than picking a color, basically every edge gets a unique color. So what we do is we randomly generate what goes on that edge, and then the neighbors are going to make sure that they match what we chose for the edge. And if you do that, you run into a problem of what goes on the corner. So the actual solution is, the first thing you do is you decide what happens around each corner. You decide what overlap, like maybe a building overlaps it. A constraint you can do that's a reasonable constraint on a city is say there's always a building overlapping every corner. A road never goes through, because we're basically making roads, lots, and within a lot there's a building. So we could say there's always a building overlapping every corner. And buildings need to have, and so then that building gets generated in all four of the chunks adjacent to it. We'll generate the exact same building description, but offset it. And so within a single chunk, if this is a chunk, when we go to generate this chunk, if we're generating, like, so say we're talking about a building, this green building here. When we go to generate this chunk, we'll place that green building here, and it'll only generate part of it. But when we go to generate this chunk, we'll place the green building here, and it'll generate the different part of it. And this is why we need the command lists, to be able to have their origin start off the edge, so that we can just use the exact same building description but offset it. So our starting point is going to be, pick a building that goes there. Now, as we said before, what is the origin point of a chunk bottom left? It's totally arbitrary, but yeah, I use bottom left. I use smallest x, smallest y, rather than the center. But you could do it whichever way. Anything would work. And you would still have this negative problem wherever you put the origin. You would still need a range that's larger than 256 for it to, if the chunk is 256 by 256, the starting points need to be slightly larger than 256 by the size of the building, basically. So what we said, though, is that when you have a building, it always needs to be part of, it always needs to have a road going by it, so that it faces onto a road. Ignoring, like, if you have a campus, or a big, basically a campus, like a college campus or a, Google campus or whatever, where you have buildings away from things. But we're talking about a city, so normally buildings are going to be up against a road. So, and you need to know that so that the building description can say which side is the front and builds the front door and the lobby, etc., on the correct side. So you have to decide that much to correctly place the building, which means implicitly you're saying, I know there's a road there. You're also going to want to make sure that the roads match up around that building. And so what we might as well do is we might as well pre-compute up front, when we make the corner, we might as well just decide the whole block, might as well decide the shape of the whole block for it. Not necessarily all the buildings in it, but maybe you just design all the buildings in it. You're just going to say, we're going to make the block shape this. Could be rectangular. You could make it non-rectangular. You could say that at a particular corner, you're going to make the block shape be like that and put buildings like this. You could decide that, but as a simplicity thing, allowing this complexity within the grid, but not allowing that complexity at the corners or across the boundaries will simplify things. So we can say at the corner, we'll just always make a rectangular block, and then we'll see as we fill in the edges. So our starting point is going to be to say, at any corner, we can generate, we get a random seed, we take the random seed for the map, and take the x and y coordinate of the corner, and combine those to get a random seed. And we use that random seed to generate a rectangular block. So these are roads. All of the roads around it cross an edge, so they're going to need to get locked down at least by the edge point. So probably at the time we generate, we decide how wide these roads are too. They can be like major roads or minor roads, right? 2 lanes or 1 lane, you know, or whatever, alleys, whatever. And so we only really need to decide this building, the one that crosses the corner, but we know we'll have to fill in this building and this building to match. We'll need to decide it as part of the edge data to make sure that they match across the thing. So we might want to just go ahead and fill out a whole block, compute the floor, basically decide what the floor plan, the foundation shape of all the buildings are. I believe what I will do is only do that for the ones that cross the edges. And you wouldn't even have to do that. You could have the edge, as we'll see, the next thing that you generate are the edges. So we could have the edge fill it in, but we want to make sure that it's plausible. So what we do is we leave a hole here, but a hole that we know that we can fill in. So basically, we know you can either just use that hole as the floor plan, or we can subdivide it and put more things in. And this square down here, this chunk is the one that'll decide how to fill that out, and these don't need to know about it. So that's how we'll do a single corner. Now, as I said, because this is what I did in ZMC2, sort of, except I didn't really understand old ZMC1, except I didn't really quite understand it as I was doing it. So I don't remember exactly how it works, but I think that's kind of where I ended up. And but the scale is very different in ZMC1. So 256 by 256 units in ZMC1, it's a much larger area. In ZMC2, it may not be that big an area. So we might do this operation on a larger scale, like on like 1024 by 1024 or something. We'll still have to do the actual trunk vertices. So this is kind of a bad explanation. Let's just stay there. Let's stay with that. That's true. I have to do that. That is what I will do for corners. Okay. I'll come back to the thing I was starting to get into. So now that we know how to generate a corner, so we're coming in, we're trying to generate a grid, a single chunk. So we generate the 4 corners. So let's look at just one edge with corners. So it generated some kind of rectangular lot. Generated buildings. Now these blue lines are roads. So we now know there's a road crossing this way here, and this way here. So we've started to describe this edge. So now what we do is we're going to generate this edge. And the edge generator will take as input the already computed corners. It could call the corners itself, but then we would just be redundant recomputing them. So you pass in the corners you've already computed. And the edge now says, okay, well, I need to decide what's crossing the edge. So what it'll do is it'll put in some roads. Again, you could have more complexity than this, but this is what we'll do. And there's two ways it can do it. It can do roads that extend a long way this way, and so they're too deep building-wise, with the buildings facing forwards. Or it can generate a long stretch where the buildings go like this, and has a road like this. So it can do both of those, and it will do both of those. It'll randomly decide how to split up this road. Now, this is where I was saying the 256 is actually small enough that there may not be very much distance between these, because buildings 256 feet is just not very long. So we might do this edge analysis on a larger scale. We might compute the edge data for 512 or 1024 so that we generate a good variety of whether the roads continue in each direction. I don't know. We'll have to look into that. I know how I did it in CMC1, but I don't know how to do it in this one. Now we have a system that generates edge data along the edge based on the corners. So when we go to generate a single chunk, we generate the corners. We generate edges that fill them in. Similarly. And then we have a bunch of roads coming in. And now we finally get to doing this chunk. And it has to resolve how the roads intersect so that everything stays connected. Then, once it's generated all those roads, we have buildings that we got from the corners and the edges. But now we can start populating buildings within the chunk. But again, the scale is probably wrong with the current scale of CMC2. Probably you only generate a couple buildings, not this many. Which is why, so, okay, yeah, sorry, to get back to that. So it is possible to just work at a different scale. We can work at a scale of like 1024 by 1024 for all of this analysis, including the corners. And then we only generate a 256 by 256 chunk out of this plan at any given time. That is a viable approach. If that is what it takes to make the road networks more interesting. So in other words, if what I need to do is generate this chunk, then I'll generate this whole plan, fill in all those details, and then only generate the stuff that only actually generate a command list for the stuff that overlaps the chunk that I'm doing. So the fact that these chunk corners are not falling on the high level corners is okay. So we may do that. We may not work at a 256 by 256 scale for this generation because it's too boring. Like if we try to do it with this method at 256 by 256, you might just end up with a simple rectangular grid that looks terrible. I don't know. Because the buildings take up so much space. Now, suppose what we want to do is include a river. So we could, there's a similar thing in CMC1, which is wide roads that extend across many chunks. But let's just use the river example. So a way we could do a river is that we generate a river crossing on some edges. But the problem is, if we generate a river crossing here and there are no other river crossing edges, then where does this river go? Well, we just have to end. And we might just end, right? We might end up making a quote unquote river that just does that. And what we want is for it to feel like a real, you could have bodies of water like that, but what we want is to feel like a river. So the easiest way to do that is to always generate two. Now we could generate two like that, but remember we generate the edges before we generate the tile. So how do we know that the tile has two edges? There's also a question of, like, you could end up creating a loop like that if that was what the two edges in every tile was. So one thing you could do is just always generate the river on the top edge and the bottom edge. And so now the tile can decide how to connect the river, and it will just be a river that goes the whole distance across the entire map, but always stays within this one chunk. And, you know, that would be okay, right? And so you'd randomly decide for every column, or every infinite column. I don't know how to draw the infinite column. For this infinite column, you would take the x coordinate and you'd pump that through a random number generator and decide, should there be a river in this or not? And and you do this when you're generating this edge. So when you're generating this edge, you take the x coordinate, pump through this number, say, should this edge have a river crossing? And then decide where it goes horizontally randomly. You could do it that way. That would give you a single river that crosses infinitely across, and then periodically there are more of them based on that pseudo-random generator. That would work, but it's not very interesting. So the only way I can see to do this and get decent results is, if this is a chunk now, is we work with super chunks. So because we don't have to do that much processing to decide where the river goes. So let's say this is 7, but pretend this is 64 chunks by 64 chunks. It's huge, covering a huge area. And we could say, well, within every 64 wide vertical strip, we'll always either have a river or not have a river. And then every 64 or some other number, vertically, we decide where the river crosses. We decide which chunk the river crosses. So when we go to generate this chunk right here, we first say, let's generate this super chunk that lives within, which is potentially expensive, but the super chunk is only going to generate this really coarse data. So the super chunk says, do I have a river? If I do have a river, we're going to say that it enters and exits here. Now, the super chunk can just decide the river does that. I don't know what. And says, okay, there's an edge crossing here, an edge crossing here, an edge crossing here, edge crossing. It can do all this work because it's actually only a small amount of work, right? You'll use some logic for how to do this. And uh, what you might want though is you want to have rivers merging, and that it's harder to see how you do it. You could say, well, there are two entries, and then the super planner decides how they merge. But where did the two entries come from above? Did they come in the above one? Was there a single thing somewhere and it split again? Like, this is a problem at infinite scale because if you have any kind of tree branching structure, like recursively merging rivers, as you go further along where they came from, you ought to have more and more rivers. So I think you just can't do that unless you're willing to do the split and merge. But you don't really want, if the river has a downstream, if the river is flowing in a particular direction, it would be weird for it to split and remerge. Not impossible, but not really a normal thing for a river to do. But if these were canals or whatever, like you could of course do it. What's the difference between the regular chunk and the super chunk? The difference is that the regular chunks produce voxel detail, and the super chunk just does planning to give you some kind of consistency across a larger scale. Again, remember I said rather than this being 7 by 7, maybe it's 64 by 64. So you're planning out 256 different intersections with where the river goes. But it lets you decide the shape of that river on a huge scale across the world, right? 64 times 256 feet is 2 to the 6 times 2 to the 8, 2 to the 14. So that's 16,000 feet. So that's about 3 miles. So this would be a 3 mile by 3 mile thing that you'd be doing this river planning on. So it would allow you to get that river to do whatever you want. In the original ZMC, I was planning on doing this for elevated roads. Elevated roads would work like this. And they could actually merge and split, and that would seem perfectly fine for these elevated superhighways. And we could still do that in this engine too, but I don't really want to do vehicles with fast travel speed. So, and any other kind of planning that we want to do on a larger scale. Like, you can have biomes, right? You can say, in this biome, we're industrial, and in this one, we're tall office buildings, and in this one, we're apartment buildings. So, zoning. And you can just do the zoning with sort of Perlin noise overlapping thing, but you'll get these weird little patches of tiny areas of biomes. So, you could instead do your biomes on a super chunk level, like, say, maybe you pick a biome at every super chunk corner. It might be a different scale super chunk. Maybe this super chunk for the river is 64 by 64 chunks, but the super chunk for biomes is 8 by 8 chunks. But let's just keep using this diagram. So you pick biomes at these corners, and then interpolate them across. And what you might do is you might have two sets of biomes that are disjoint. Like you have industrial and this and that and the other, and you use set A at this corner and this corner, and you set B at this corner and this corner. And that way the corners are always different, so that you always get biome variation across this scale. Or you don't, and you allow sometimes the same biome gets generated and you get a larger area with that biome. Another thing the biomes could be is like, the poor neighborhood versus the rich neighborhood kind of thing, which will connect to that zoning as well. But, do you have high quality apartment buildings or do you have cheap apartment buildings? So you can run all of those processes at different super chunk scales, because all you do is you say, I'm generating this chunk. So let me, do some math to figure out what the super chunk it came from is. And so here's the chunk that I'm doing, and you do some math and you figure out, well, the the um, the superhighway chunk that it comes from is this. The biome chunk that it comes from is this, and the river super chunk that it comes from, heck, maybe they don't even nest, although they probably want to be powers of 2, so they probably do nest evenly. But you could say the river super chunk that it comes from is this. Now the first thing that you do is you generate the corners. So each corner is going to say, well, what zone am I in? And those, you probably want to structure it so all 4 of the corners are actually going to compute the same things. So this might fall right exactly on that edge, and then these ones will still push out to the same 4 corners. So each of these corners can like say, okay, where are whatever the superhighways that are neighbor to me, and so this is again kind of that phased operations. If you guarantee this nesting, so that all 4 of the corners are always going to come from the same things, then you can actually do that. Phase 1 is you push out and you find out the river super chunks, and you generate the river data. Phase 2, you push out from this and find the biomes, and you can do biome interpolation down to these corners and figure out what biome each corner is. And then you have the superhighway thing, and you generate the superhighway data. But you don't actually figure out the biomes for these things yet. You just do all of the river processing. You do all of the biome corner processing, preparing for interpolation. You do the highway thing that plans where highways go. Now you finally get down, and now you've got the 4 corners, and you say, okay, for each corner with all of that data that I've accumulated from the outer things, compute that corner, compute that corner, compute that corner, compute that corner. Now that you computed the 4 corners, you compute the 4 edges. Now that you computed the corners and the edges, all of which we're drawing on all that biome data and everything else, now you finally can interpolate over your interior chunk, and like, you probably just sample at the center of each building what biome I am, or maybe you do it for a whole lot, for a whole parcel, block. Maybe you make each block be consistent. So you determine what biome a block is and make all the buildings in that block consistent. Sure, I guess. Macro level playing. But the problem is that you can never get outside of this idea of some chunk of the world. Like, it's never truly infinite, right? You're always saying, well, I'll chunk it at some scale, and what happens, there's no planning that's happening across beyond that scale. The planning can only happen within that scale. Which is exactly like, if you think about what a single chunk is doing, a single chunk has to figure out how the roads intersect in a sane way. And that's a little bit of sort of road planning. And so you can think of all of these things as you pick some scale on which you're okay with it being homogeneous, and then you allow planning on a finer scale. There's the data for highways randomly generated along the edges. So the highways would be if we did a highway planner, it would look something like this. You would say, so the idea is that the highways are elevated superhighways, and they don't want to collide with buildings, and they're allowed to curve, unlike the normal roads that are just straight. So what happens is you would pick some scale that you're doing the superhighway planning on, and it would be a pretty large scale, and you would do something like generate on this scale 2 superhighways on every edge. And then you would decide, how do you want the superhighways to connect? Like, maybe it's that. Who knows what algorithm you use to do it? You could always pick pairs and just connect pairs and then add intersections between them. Or you could try to do more sophisticated stuff like I did here, where this one splits into 3. But you just guaranteeing connectivity. And you could even do something where, like, on each edge, you generate one or two superhighways. And then it's up to the interior planner to decide how to connect. But this is all happening on a much larger scale than the chunk. When you get to a chunk, now you say, okay, the superhighway told me that it enters here and exits here, and it's up to me to connect them. And at that scale, I probably don't have very much freedom, and I just follow a path that's already been planned. But potentially, I could do something like, if there were a tall building, I could route around it or something like that. But mainly, what I would do at this point, I would generate the data for the superhighway, and would make sure any buildings I generated stayed under the superhighway, because the superhighway would be this very high elevation roadway that allows buildings to generate up to under it, but only up to its elevation. Yeah, and then you need some way to get between the highways and the regular roads. But like if you look at Vuntra City, which is a procedural city game that is being developed by an indie developer whose name I don't recall, that, which is not Infinite City, it's a planned city. But she's doing a similar thing to these elevated superhighways, but they're elevated trains. And so all they need are train stations. And so what you do at that level, you wouldn't even necessarily need this planner to do it. You would just, in this chunk, go, oh, should I try to put a train station here? And so you just make a tall building that goes right next to the train, and make that tall building have a platform onto the train. And that way you don't have to deal with on and off ramps. So that's kind of a better match for this than what I was picturing. I was picturing these super highways, but I didn't have ramps because they were too high. Yeah, let me just let me get you a link. So there's the elevated trams. So anyway, the upshot is we can do whatever kind of plane we want. This idea of the superhighways, like I said, I conceived it before Voxel City, like more than 10 years ago. I conceived it as these superhighways that you could drive really fast on to deploy to missions, but that it wouldn't have direct connection to the ground for the vehicles. Like, in other words, they were like, you can imagine it's like, high-speed rail, but for vehicles. Like, maybe they would be these high-speed vehicles that would be up there that weren't meant to drive in the city proper, and there would just be vertical transfer stations. But I mean, I never really fully figured out what I wanted there. It was just kind of an idea, and her approach is like clearly like the rock solid version of that. And maybe I don't know, maybe I'll steal it. The because it's voxels, it's a little weird to have it curve. Like I'd be okay with vehicles, drivable vehicles that turn off the grid would be okay, but having fixed train like rail vehicles that don't follow the grid feels a little worse to me because they're not under player control. They just spontaneously are turning to angles, so I'm not sure I'd like that. Um, Maybe I do elevated straight only. But anyway, so yeah, so the point is we could generate arbitrary different scales at which we do planning at different scales to make sure we get features at those scales that interact interestingly that we can't just compute at the chunk level. That's the basic idea. That's the simple pitch. And the hard part is getting everything to be coherent across a single chunk. But for that, we have this specific strategy using corners and edges. And then when we go to these super chunks, they also use corners and edges to do their planning. Like I talked about how the biome scheme would compute biomes at corners of the super chunks. And you could do more, like maybe interpolating biomes from corners is too obvious the effect in the world. So you could also spot place some biomes within super chunks. Maybe want biomes that have specific shapes, like maybe there's an industrial area that should just be a rectangle, and so you just place that in the biome planner. Just says, I'm interpolating the corner biomes for some of it. That's the background is the interpolated biomes, but then I'm just going to place, here's an industrial thing, here's a campus that crosses across multiple chunks. Like say you want to do that, say you want to make a Google or a corporate campus or a college campus, and it just needs to be bigger than 256 by 256 feet. So you just place that. Maybe you want to make a warehouse that is 1,000 feet long. So you could do that in a lot of different ways, but a simple way is to do it on something like a biome planner that just says, oh, here's this building here, and it has to override all the normal chunk computations. Like it crosses over the corner of chunks, and the chunks just have to say, well, it's okay, I have a plan. It's this warehouse. I'm just going to place this warehouse down. So it's prefabs, but you would still dynamically build the warehouse. But it's a little bit more like in NetHack or Rogue, I guess Angband and Rogue, not Angband and Moria. I guess NetHack probably has it too. You have vaults or things like that, which I guess they're still actually kind of fixed shape, but you can imagine that they're procedurally shaped, but they're still special. Like, in other words, I have a right, we have this building generator. This is the old CMC. Hang on. We have this building generator right now that doesn't generate windows and that generates windows in kind of bad places. But that's parametric in terms of how tall the floors, how tall the building is, how tall the floors are, what the window shapes are, and that's about it. So you could turn this into, okay, this is an office building generator that generates basically this shape, but populates the interior. And you could make like variants of it that have different ways of generating the interiors, but share the exterior. And then you can make a special thing for the bottom floor because the bottom floor is like retail establishments. And so the bottom floor is special. And then you stack an office building on top of it, of the bottom floor. But that's just one building generator. Then you might make a building generator that's like, well, I don't want a flat front thing. I want it to, I don't want it to just be a box. I want to get narrower as it goes up. So you make a building generator that can get narrower as it goes up. And maybe it uses the other generator as a tool to do that. But then you make one where it's like, well, I want the front to stick out. Like, I don't want the floor plan seen from above to just be square. I want it to stick out on the front or on the back or stick out in multiple places. And so you write a generator that can do that. You don't necessarily write one generator that can do it all. You might just write a different separate building generator that can do that. Because now the interior also needs to account for that. And you can do that, like procedurally. You could say, well, I'm going to define the floor plan as a sequence of connected line segments and then write a universal algorithm that knows how to solve it all. And I feel that's how academics would tend to do it. But in the game development, it's pretty common that you would just say, no, you know what, I'm just going to write, 5 different building generators. And by the end of the game, by the end of development, maybe I've written 50 building generators. And so one of those building generators is a warehouse generator. And that warehouse can fit within a single chunk, but it can also, it's parametric, and so it can just be extended to be 2,000 long, 2,000 voxels wide. And now, but to place one that's 2,000 voxels wide, you now need to do this crazy biome stuff to make sure that it's well behaved and interacts with everything else. So you could potentially have the single thing. Did you nail your keyboard to the wall? It's attached to the wall, but not with nails. So they're not exactly prefabs. There's just, you would make a whole bunch of building generators, and each building generator, you're thinking about it in terms of, I want this to be as reusable as possible. So you want it to get as much use as possible. So, you can't have unique one-off buildings, but you might try to find a way to make a generator that makes unique one-off buildings, or that you take an existing building design and add a thing that builds a new facade for it that's unique, but it still uses the regular building generator for everything except the front wall or something like that. There's a bunch of things you can do for that. We'd probably make a building roof generator that generates the top of the stairs, and that puts air conditioning units and other stuff on it. And we might just make a couple of those generators, and then when you generate a building, you randomly choose which of the roof generators to use, so that they're not coupled. You might do that. You might have interior generation. You write a couple of different interior generators that know how to generate a rectangular interior and reuse those across different buildings and separate out the facades. There's a bunch of ways you can do that. But anyway, yes, there is a keyboard attached to the wall. It is the keyboard that I use. It's another of the keyboard that I use. For all the people who kept asking what my keyboard was. So, because I have like 20 of them, so I took the one that was the most broken and I put it on the wall. All right, so what we need to do, we're going to make a grid of chunks. Say 16. Chunk, pointer, map, chunk, map, size, chunk, map, size. Then we're going to say void set map. Oops. And we do x and equals chunk map size minus 1, y and equals chunk map size minus 1. So we'll use a wraparound map to store the local area around the player. So we're going to say map of y of x equals c, but first we say if map of y of x is not null, then 3 chunk. Yeah. we say set map x, y, x026, y026c. And actually, there won't be any free chunks to allocate if we don't do that first. So we say clear map oops that goes away anyway. Free chunk, that's not I don't know what I was writing there. That's not what that code is supposed to be at all. Free chunk of map of y x, and that'll free up a chunk. So then we can say clear map of x/26, y/26. I think that works. So now we take our camera location, we do get map So now the logic is when we're here, we have a J. So now we say for J equal, let's say, -3, for I equal -3, I less than equal 3. So we want to pick what chunk are we in. I guess we can just do this way. So chunk position is x, convert int x to int, divide by 256. That's not C syntax. So that's the chunk we're in. Okay, we need to be consistent about these. Let's say that chunks, this call is always going to be at this scale, in the chunk space. So these are all that, but this can then be that. So we say if j times j plus I times I, so we want a circular radius around it, is 4 times 4. So the chunk that we want is cx plus I, cy plus j, and we say chunk asterisk equals get map cx cy, And then if cx minus I times cx minus I plus cy. Well, it's if c arrow, okay, origin, let's go to chunk, also store cx cy, x origin, cx equals x, equals y. The thing to realize is that when you do Perlin noise, when you do FBM noise, where you sample multiple octaves of Perlin noise, the Perlin noise is building a grid, and you're sampling in the middle of a grid, and interpolating the values that you got at the corners. And then when you do the FBM noise, it's using a coarser and coarser grid. So the Perlin noise is coherent. The FBM Perlin noise is coherent across a large space because it's actually basically doing super chunks effectively. So now we have cx_cy, so we can say if c arrow cx does not equal cx, or c arrow cy does not equal cy, then we can clear that map. Clear map and int did any actually yeah, let's just use a go-to. Done. So if it doesn't match, then we actually just want to build it. Make chunk. And then here we want to recapitulate and go to done, because we all know we want to make one chunk per frame. And then I have no idea that any of this works. I wouldn't expect it to. Oh yeah, I have to check for null. Yeah, we will always, or c arrow cx does not equal cx, or cy does not equal ccy. That's what that should be. If c is null, continue. I have to restart to be able to build. Okay, I think it's building every frame because of my frame rate. Oh no, that's just because I've built so much data. But I didn't build anything behind me. I don't feel like this worked. All right, let's use a smaller radius here. Oh, we need to free stuff when we get out of range, which we're not doing here. So if we're out of range, else We could keep it cached, but because we're always, we're not always rendering it. We can keep it cached. Let's do this anyway, to start with. And let's change this to only go from 1 to 1. So it should just always draw a 3x3 around. It should, in theory, should always be drawing 3x3 around the camera. But I'm sure I'm missing some logic here. Free VBuff. So we tried to free something that we hadn't allocated, which is this chunk. Not sure. Let's make sure we zero these though. Oops. It's not going to the negative ones. Is it building around us? No, it is not building around us. Okay, well, it's stopping drawing if they're too far away, at least. Why are we not building around us? It's probably making them and not rendering them. That would be my guess. But, well, we can break in the debugger and see. Why, as I get further away, is it populating further away? X and Y are positive. Shouldn't X and Y be negative because I'm going away from the origin? These are negative because they used to be translate calls. So these need to be positive. That's why it was doing it. But now my movement is backwards, so we need to fix the movement. Oh, and Z is also going to be backwards, probably. Everything is totally broken. Why is everything totally broken? Okay, first of all, my movement is backwards. Oh, yeah. Yeah. I don't even know what camera pause is being used. I'm still using I don't even think camera pause is being used. Oh, it's being used to decide which face to show. That's all it's being used for. And that's why the faces were rendering wrong. So the X, Y, Z in here are backwards from what they used to be. Or something. So I don't know how this ever worked. Okay, well now they're definitely backwards. Um, so is there still a GL translate call? Okay, so these need to be negated. And then this does need to be negated, which is as it should be, because moving W should move you forward. Although it's processed through that, so who knows? Okay, there. Now it is building. Okay, so now we can push it out the radius again. Do that. Bound to draw indirect buffer is not large enough. C arrow mesh slot is -1. Why are we trying to draw C with a mesh slot of -1? Mesh slot. Alex slot. Don't we check Alex slot? Yes, we do. How would that ever happen though? Allocated is true. I mean, actually these should be initialized to -1. That's actually fine for it to be -1. Yeah, we set it to -1 when we do it. So how did we end up? Oh, we don't check if it's allocated. Well, no, we should null it. Clear map didn't zero it. That's why. That was the bug. And our frame rate is low because we're not doing frustum culling, so we are drawing the stuff behind us. Oh, we ran out. We allocated all 100 vertex buffers or something. So let's see what's going wrong when we try to make a new chunk. Okay, it's trying to make a new chunk. So it clears the map, tries to allocate a chunk, and it fails. So all the chunks are allocated. Because we never freed. Yeah, we need to free a different slot than that. So what we need to do is do this. If it's less than that size, else if it's out larger than some size, greater than, say, 5 times 5 is 25, 100. Let's do 4 times 4. Then we want to clear it. And we'll loop over a much larger region just to be on the safe side. So if we're close to the camera, we try to build a new one. If we're far enough from the camera, we free that one. And then make sure clear map is freeing the chunk. Freeing the chunk is freeing the V buffs. We're still not generating the negatives for some reason. Oh, so that might have actually been, maybe I turned around and went into the negative region. So let's just make sure we go in this positive region and see if it runs that. But the negatives shouldn't be a problem. Negative ought to work. Although maybe I have that stupid rounding to 0 problem. Yeah, this seems to be fine. So either it was the thing I just did, or it's... why are these all the same height? Wait, we've lost that. We're no longer building different data anymore. Oh, I know why. Because we're calling build map. This one takes these coordinates. But all right, so why is negative not happening? We mask, so if it's negative, the mask should wrap around properly. This divide rounds in the wrong direction. So we want to take a floor of that. And we might actually want to round that, I think. Still not generating anything at negative. All right, let's go this way for a little bit. So we're only generating okay, now we go in a bit this way. Okay, now we turn 90 degrees left and we see, is it generating behind us? And it is. It is still generating the negative stuff. It's just only if the absolute positions are negative that it breaks. But I don't know why it would break with negative absolute positions. And there it breaks. What is... This is still going negative. Well, yeah, that has to work. Something fails if CX, CY is negative. I need to actually put a breakpoint on that. Alright, so we're trying to generate a negative thing. We clear the map. We allocate a chunk. We set our origin. Called build map. Build map don't care. We call build voxel chunk. It shouldn't care. Everything's relative to the coordinates. We call set map. Y is 12, X is 15. So now do we call this with Y of 12, X of 15? Yes, we call it with Y of X 12 of 15. Y of 12, X of 15. We return a chunk. The chunk is not null. We set the camera pause. The C origin is X and Y. Why would this fail? Now it's just in the shader, and the shader doesn't care about sign. I mean, the vertex shader has the face pair stuff. Maybe that breaks. Don't tell me that that's a uint. Yeah, I could have seen it from this. It's a UI instead of I. Wrong type of component. Chunk origin pause. Now it's a 2i. Chunk origin pause. Oh, this is supposed to be IVEC. Still not drawing them. Chunk origin pause can be negative. This is now an int. Voxel position is relative to that in ints. Voxel pause is an int. We convert it to float for this comparison. And we use voxel pause down here. There we go. Now it's drawing in all directions. All right, there we go. So now we have chunks working. They scroll around as you move. So we can start to do a city. We need frustum culling for performance on this hardware. So we need to do frustum culling. We should probably do the ground just so that it doesn't look so dumb. We can just do a flat ground though, right? We can just put in a flat slab. Main build map. P equals put slab base P 0, 0, 0, 0, 0, 1, 256, 256. Oh, you can only go up to 255 because the length is limited. Asphalt is 1. Oh, it takes X and Y as parameters. XYZ, XYZ, text, text. Base P, XYZ, XYZ, text, text count. That looks right to me. Parameter 1. Oh. Base is command data. And address account. We start under the thing, and now the buildings need to start. All right, so the slab is at 1 to 2. So the building, let's start with it hovering. 5. Oh, it's the problem is just the walls are the asphalt, which is a total. Right, okay. Obviously we need lighting. Maybe let's do hacky lighting actually real quick, because there's a very simple hacky lighting you can do, which, especially since we're already writing out a color. Float brightness 6 equals east. We'll do 0.75. West will do 0.25. North will do 0.65. South 0.35. Up we'll do 1.0. Down we'll do 0.25. In color times equals brightness of which base. except we got it wrong, I think. Because that's the east face being dark instead of the west face being dark. I thought that's east. No. Oh, this is weirdly ordered. This is ordered negative x and then positive x. So these are all backwards. I mean, not that it matters, but it matters for this one, for the up and down variant. So long-term specific game goal. There was a specific. This is based on an older engine, CMC1, that I had a very specific game design idea for it, which is Zombie Mega City. It's an infinite procedural city populated by zombies that you'd be a multiplayer team player versus enemy game. Whether that would still be the game design for this, I don't know. Okay, the hack lighting is fine. It's just too extreme. Okay, that's more reasonable. The stairs are broken here in this one. It didn't generate landings. So there's some kind of bug in this one. But I think we got to do frustum culling next because it's just the frame rate. It's too sucky. Yeah, we're not hitting 60. But how would that... There's no way that one thing should have been too complicated because it's not that tall. So it shouldn't have too many things. So I wonder what went wrong. All right, if we make all the buildings smaller, we'll have fewer quads. So this should be a little bit faster frame rate. I need to start the camera up higher. Yep, frame rate's faster. So now we can push out the rendering distance further. And then none of this should be hard coded to. So 5 by 5, a 5 radius is 5 by 5 in a corner. It's 25. That's 100. So we don't go much bigger than 5 by 5. So we go 7, 7, and we build it if it's five by 5 minus 5, and we destroy it. That won't work. Yeah, we need the ability when we try to generate it to clear not just the one that goes in that slot, but to clear some other farther one. So I think in this case we just have to do that. We can't cache them with the current logic. We need to make a smarter system. So we'll just always clear it. And then this can now go to so now our view distance is just a little bit further. And then we'll go into voxel vertex and we say off rel pos equals voxel pos plus vert offset vec4 minus camera pos out vec3 rel pos. And then in the voxel fragment we have in vec3 rel pos float distance equals, is there a distance function in OpenGL? I think the rel pos. And then fog vector equals exponential of or pow of I don't know, 0.9 negative dist. And then vec3 fog color equals, we want to use the clear color. And then we say out color equals lerp of fog factor. As this gets large, this becomes wait, is this supposed to be a small number? Because it's with negative to negative distance? I don't even remember. Fog, let's just do out color. Fog color. I don't remember what order this needs to go in. Fog factor, out color, RGB, fog color. What's implicit? What? Implicit cast. Oh, in the vertex shader. Define variable rel pos. util not define ler? This doesn't include util. Oh. And then that's used in this one, I think. Okay, totally wrong. Still totally wrong. Is it positive dist? It's a negative exponential. It's what you normally do. Is that because this should be positive? Okay, yeah, it is backwards. So this could be positive 0.95. There we go. Now we can see the pop in again. Now we can't see the popping. And let's hack this. Let's add 2 chunks to the distance and then turn up the fog. Sorry, subtract. So the fog doesn't start till a certain distance away. Yeah, there. This is totally fake, but we'll make it a little more pleasing. I guess what we could do is from 0 to 512 remap to 0 to remap to 50 to 250. So we want linear remap. T, float A, float B, float C, float D. And the function is return T minus A times D minus C over B minus A plus minus plus C. So if D is less than 512, dist equals linear remap. Dist from 0 to 512 to 50 to 250, else dist equals linear remap. just of 512 to say 2048, well 4096 let's say, 2048 remaps to 250 to 2048. Still too foggy up close. Oh, because this went the wrong direction. This wants to go -50, negative 20 to 150, let's say. So it's less obvious that we're cheating the fog, but we're still cheating the fog. That's good enough for now. And maybe we want to see the pop in for debugging purposes, but we'll use the fog to make it a little less objectionable. So now we know it's happening, but we know we can hide it really easily. All right. So that gets us, we can generate large-scale city. We have a fake ground. So we could work on the road network, or we could work on generating buildings. And I think I don't want to work on generating buildings until I have real textures. Fog factor. Just I want to check what the sign is of fog factor. Is that going to make it more foggy or less foggy? That makes it more foggy. So this is backwards. Well, yeah, it's backwards. On the fog factor 0, yeah, it's backwards. We want, when fog factor is larger, we want it to be the fog color. Okay, and so then so here's another way to cheat it. Which reduces the fog immediately around the player in a different way. Yeah, we don't need to be that slow though. Let's see what speed we're moving at here. Control is slow, so let's switch that to being fast. So what did we look up? We looked at the movement speed, and it was super athlete is a 10-second 100 meters, or 10 meters per second, or 30 feet per second would be the extreme athlete. So let's try that. Start the camera above the ground. Okay, so here's a running speed. walking speed, running speed. Yeah, it's a this none of this is the final building thing, but the stairwell, there's a stairwell generator, so you can generate multiple stairwells. It's not a problem. So none of this is meant to be the final buildings. I should have searched for it instead of trying to scroll through it. Right here. X0 plus 10. 26. X1 minus 26. X1 minus 10. There. So now every building should have 3 stairwells now. Or only 2. Oh, if they're too small, they overlap. And we're generating too many commands or something. We're losing some of the commands. Yeah, I don't know. Yeah, it's because they're overlapping each other, I think. Yeah, this one is getting overdrawn. We just made that stairs because I needed a system for generating the stairs because of the way we build the voxels in the compute shader. If I used the existing set of primitives that I had, the stairs would have been too expensive to build. So I had to add a new primitive method that basically just builds stairs. And so we had the stairs in as a test, so we could see it. So walking speed, running speed. God, you can't. Running speed, falling without the appropriate speed, and control to move fast, and control shift to move really fast. And then for anybody who's new and didn't see this before, this is the old engine from 12-ish years ago that I'm kind of remaking. But in this one, all of the generation of the buildings happened on the CPU, and I did not get very far in building generation. And my near clipping plane is not in the right spot, but you can see very fake interiors, and they have grass for the floor. But so this is where we're headed. But with the voxels are half the size, so there's 8 times as many voxels in the new engine. And we're still in the early stages, so we don't have any of this complexity yet. Could you implement dynamic holes by removing textures from selected voxels? You could implement dynamic holes by removing the voxels and remeshing, but because this is a meshing based engine, its intent is to not do dynamic voxel stuff. Voxels are just being used as a visual aesthetic and because it makes procedural generation easier. But it is not intended to be a dynamic voxel world. You could make one. I wouldn't do it with this engine. Do you have camera culling built in yet? If by camera culling we mean frustum culling, no, there's no frustum culling. Currently, it's drawing. The stuff that's behind is still being drawn, which is why the buildings are short, because it got really slow when I didn't shorten the buildings because it's drawing so much stuff behind. Let's go this slow path. So you can see the frame time is 30 milliseconds, but we have taller buildings. But it's only slow because it's still drawing all the stuff behind us. So it's drawing about 4 times as much stuff as it needs to. Of course, drawing 4 times stuff as it needs to, if we cut that down by a factor of 4, then when we want to do lighting from a sunlight, that lighting will require drawing shadow maps, which will eat back up rendering all those millions of triangles again. Let's somewhere we had a thing where we computed what is it? Get? How is it? Get? Is there a get? Yeah, it's this one. Mesh count. Is that what we're using for our... Yeah, it is. Okay. So we want to get offset 256 times C arrow mesh slot. And we want to store that into C arrow mesh info, which is just that. Now quads plus equals C arrow mesh info 0 over 4. Int quads. So before the loop, initialize quads to 0. Now we know how many quads we're drawing. Hopefully. $40 million quads. Now, why is it not faster drawing 40 million quads than the STB voxel render demo using an older GPU, the 680 Ti? I don't know. Oh, I guess because half of the quads on the 680 Ti were being backface culled, and none of them are being backface culled on this. But anyway, so yeah, so instead of 4 million quads, we'd probably be drawing 10 million quads. Yeah, the thing is that this engine is a rasterized voxel engine where we just turn the quads, the voxels back into regular meshes. So it doesn't make sense to try to do ray tracing on the voxel data because we're not storing. Well, what? Those are tiny windows. The data isn't in an appropriate form to ray trace, so it makes more sense to just treat them as once we've got meshes, treat them as meshes. It's like I said, it's just procedural. It's just voxels for the procedural ease of procedural generation and for the aesthetic. We're not really treating it as a voxel engine beyond the proc gen. When rendering the shadow maps to be a lot faster, normally the fragment shader, you are saving that, but it's not the fragment shader that's killing you here. It's drawing 40 million quads. Like, you know, a 2K by 1K is only 2 million fragments. So the amount of fragment shading work you do is totally dwarfed by the rasterizer drawing the shit ton of. I mean, it's only 10 million quads visible because of frustum culling, probably. Ballpark. But there's way more quads than fragments. So the savings you get, it is true in a normal engine that you do get to disable the fragment shader and shadow rendering is often faster. But basically, the point that I was originally making is that if we think of the cost of rendering as the sum of the fragments that we render and the sum of the vertex shading time, vertex triangle processing time that we spend, if I cut this down from 40 million quads to 10 million quads without changing the number of fragments because I'm frustum culling, but then I draw 10 million more, or let's say I, for whatever reason, I drew 3 shadows that had to draw the full thing. So I drew the same 10 million quads another 3 times, but with no fragment shading cost because fragment shading is free. I would still be paying the exact same cost I'm paying right now on those triangles, sort of. Yeah, there is no LOD for the buildings, and there won't be. I mean, you could generate voxels out further and find a way to simplify the voxels. Because we're command list based, you could even simplify at the command list level. So like, you know, rather than generating the voxels at the full resolution and then shrinking them, you could round all of the command lists up to the nearest multiples of 2. The reason to round up consistently is then like a line to multiples of 2, because then things like the windows being holes, like now all of your walls will get 2 voxels thick. 2 voxels that then becomes 1 voxel when you scale down. But like if you imagine working in the scaled up space, now your walls are 2 voxels thick, but your holes for the windows are also 2 voxels thick. So you could do something like that, and you might by doing it at the command list level, that might actually give you an effective way of like not losing holes, of keeping the topology relatively similar. So that's certainly something we could look at. I don't like it because it pops. Like that's the whole thing with the other project, the terrain generator thing, is trying to do LOD that never pops. So I wouldn't really like the popping when it switches levels. Do you have to render all the geometry for each cascade? I thought if a geometry is full inside one cascade, you wouldn't need to be drawn for those. Yeah, you don't have to. Like, so that's why you wouldn't actually need to draw 10 million things. It's a little hard to be fine-grained, though, because if you're just storing a whole chunk and the chunk is this whole height, so the chunk is 256 by 256 by 1024, then, you know, if any part of it touches the visible cascade, you're still drawing all of it. But yeah, you wouldn't end up drawing 3 times the number of triangles. You'd probably be drawing more than 1. Also, keep in mind that you actually draw more because there's no behind the camera. Like you're you're taking what's visible in the frustum and then generating a straight line away from that towards the camera, towards the sun. Uh, that's actually potentially a larger amount of stuff, so it doesn't get frustum filled. I have no idea what's going on. Well, this is what's going on. We're generating an infinite city in real time. With bugs. With lots of weird bugs that I have no idea what they are. Why does this one have no windows? Why do the floors run out part way up? I have no idea. You could have a way to save their command list to debug later. Well, fortunately, I can just rebuild it because it's procedural is supposed to be consistent when you come back to something. I guess here, let's find a buggy one. Here's a buggy one. And let's fly for a little while at high speed so it gets freed. It should be freed by now. Now we turn around and fly back, and it should generate, if not the exact same bug, certainly something buggy. Yeah. So yeah. So you can always go to a buggy one and hit a key and say regenerate this, and then debug it. So yeah, maybe I need to make tools for visualizing the command lists. Single step through the command list, right? I could rebuild the mesh and like I could say, here's the command list, but only build the first n things of it and then be able to sort of advance through that. But I don't even know that I'm going to do Cascade Shadow Map Shadows, because one thought is that it's this foggy city, and so the fog means the sun isn't visible. And so it's just lit by this sort of ominous blue lighting, and there won't be any shadows, except for flashlights. Because my thought is that it's going to be very expensive. Once there are interior walls, it's going to be very expensive to try to figure out how much of the exterior is visible. So I think what will happen is that in the building generator, it'll just tag areas as near windows. And so then the areas near windows get a little bit of exterior light coming in, and any room that's further interior is just pitch black. And then you would have flashlights to let you see them. Except maybe then you can turn on the power, and turning on the power would fix things. And so then with the power on, the interiors would just be lit in a sort of fake way. But anyway, so I think what I would do then is I would have the building interiors do this fake calculation for whether they're being lit through the windows. But then exterior will do a more accurate calculation of how much of the sky is visible and be lit by that sky directionally. I do plan on hooking in a PBR shader and having the walls have bump maps so that when you look closely at surfaces, they are lit in some way that sort of reflects reality rather than being totally fake. That may be overkill, but I have the code, so I might as well just drop it in. Yeah, I think the exterior, what the exterior would do is just treat each building as a solid rectangle and do some very simple math to determine how much of the sky is visible based on that. They would probably just all live on the CPU. There'll just be a CPU lighting engine that runs after or before we generate the thing. Boy, this is really confusing. Okay, there we are. Okay, here's the stairwell. It doesn't quite connect correctly to the landings. That's weird. One landing does, but then another landing doesn't. It's got these weird doubled replicated landings that don't match. This side, weird. Somehow the spacings of the landings are wrong. Is this voxel safe for a tech demo or is it part of a game? I don't know. I'm just starting by doing the tech. The unique look comment, it's kind of what you need to do in a city, like for the city to look right. Like these walls in here ought to be a lot darker because they're not really catching much light. It's naturally what you would see in a city, and it just will make sense if you do that ambient occlusion, basically. I don't know that the interior hacking will work, but trying to do a correct calculation just seems like a lot of unnecessary work. I mean, it could always just be done in the background on the CPU slowly and like populate in as it computes it, as it figures out a better estimate of the lighting. But then you need to store it somewhere, and you don't really want to store lighting for every voxel. You could store lighting for every floor quad, basically, and extrapolate it up. But even then, in these buildings, we have lots of floor quads, so it would require a pretty large amount of data on the CPU just to store it. All right, so what could we do now? We could write a system to help debug what's going wrong. Let's make a toggle to turn off fog. Actually, into this. Oh, no, it's ap.input control. Okay, and then let's make the fog go up to 9.5 so it actually fades out. Let's make the buildings not be hovering. I made the same mistake again. Do I need to start it? Oh, right, Z. Z should be 2. Okay. All right. And then we can turn off the fog and see them pop in. Okay, and then if we press V, we want to remesh the current one. So we do this. Do chunk asterisk equals get map txcy, and then we say make chunk txcy. Maybe. Yep. And then we would say debug chunk equals 1, debug chunk equals 0. Bad habit of not using booleans, because for SCP libraries I always use ints. Since there's no default type, it's not worth defining it in every library. Okay, so now we've turned on debug chunk, and now with debug chunk on, we do this. Debug chunk min of count, or I guess std min count and debug count. We don't need this for changing the Z elevation anymore. We don't actually even use it. Debug count minus equals debug count if debug count is 0, then use count, otherwise use the min, otherwise use count. Okay, so in theory that will let us debug the chunk we're standing in. So we press V, and it instantly remeshes. So then we change the debug count. Okay, what we need to do is make the debug count V turned on debug count. Right, I see. What we want to do, void debug build float x float y. We do all that. Debug build XY. So now when we press a key, it'll update the thing. So if we press equals, that's supposed to only be one command. That's a lot more than one command. This shift thing isn't working. I think. I mean, I don't know. Let's check what debug count is. Debug count is 1. Okay, if debug count is 1, then that should have uploaded 1 to command list. Debug count is 1. Command data is 1. So why is it building all this other stuff? All right. I want this to be faster, so main int chunk radius equals 1. Chunk radius times chunk radius minus 2, let's say. All right, let's put it down to 1. See if that only does 1 chunk. Does 0 chunks. Plus 2. Well, that's doing it out a ways. Oh, because 0, 0 should always happen. So it should have been, this should have worked. This should jar one chunk. Why is the one chunk not getting created? Oh, wait, why am I looking at CXCY? I want to look at I and J. Okay. Oh, because I'm subtracting 2 again. Yeah. No subtract. Okay. Okay, good. So now we just have 1. So now if we press equals, it draws a whole bunch. It's drawing the windows. Build map. What do we do in order? We draw the ground, which is 4 slabs. Then we call create building. The building is 4 wall slabs. Then the windows. So we're getting 3, 4, 6, 12, 18, 24 windows. 4 slabs is 28. 28 walls. And 4 ground slabs is 32. So even though we're asking for 1, we're getting 32, which is suspiciously like the number of jobs in the command list color. So I suspect what's happening is this is not correctly culling. Yeah, it's not. If slot is greater than or equal to num commands break. There we go. That'll probably fix it. Oh, there were 2 issues. This is using is down instead of was pressed. One, 2, 3, 4 slabs, 1 wall, 1 wall, 1 wall. Then we'll do the floors. Then we draw the hole for the stairs, or for the elevator. I don't remember which. I guess we're doing the stairs first. Then we draw 1 stair. Then we draw the other stair. Then we draw the wall surrounding it. Then we draw the landing. Oh, then we draw the middle thing. Then we draw the landings. Okay, that's all working. So now we put the radius back up. And we start looking for buggy things. Put the radius up higher. So where's a glitchy one? What happened to all the glitchy ones? Thank you. It's all just a quick hack that I did earlier just to get a sense of what it would look like. Come on, where are the broken buildings? Come on. Did I change something that, yeah, and now it doesn't, they don't break? You could see that, you could see them while I was moving. You could see them through the thing. That might just be Z fighting, Z buffer, Z precision. I might not have tuned the near far plane properly. Yeah, maybe maybe it was dependent on the settings that I was drawing them out to the specific distance I was, caused them to fight with each other more, to generate faster, and so they were fighting with each other or something. Because yeah, I don't see it going wrong anymore. So that does seem suspicious that it was some kind of race on the GPU. Although I'm not sure how exactly. That really looks like Z fighting, which rather than, which it shouldn't do. Like it shouldn't generate multiple voxels there. Wait, what happened to the interior core? Where's the core? Oh. I just was past it or something, I guess. Okay, yeah, it's here. So if I go above the core, do I see any? I don't see any Z fighting. Yeah, it's okay. So yeah, it is just some kind of far clipping plane Z precision issue. Maybe I only have a 16-bit Z buffer or something. And yeah, that glitching clearly is only happening because of the other glitching that's not happening anymore. Was clearly due to having the thing generating 40 million quads. Something was hitting some limit or something was overlapping. Which is fine. Like that code, that part of the code was all pretty rough. Let me check in. And we can talk. I guess I should leave it running. So what should I do? I've added those features, so next time that we're in the state, I can try to debug what's going wrong with them. But I don't really feel like trying to recreate the state right now. So we could go to working on the road network. Actually, I'm at 6.5 hours, so I might stop, although we just got a raid, which is kind of unfortunate. This doesn't need to be highlighted anymore. Let's see. Yeah, I think I don't want to start tackling the road network, the generating the correct chunks, the chunk corners and all that stuff instead of this hacked thing. I don't think I want to start that. We'll do that tomorrow, maybe. So the question is there something quick that I can do? Um, maybe I should recreate it and try to find that bug. Oops, closed the wrong window. Stream info. Can we recreate it? Let's see. It was like 5 times 5 minus 2, maybe? Something like that. Less than equal to 5 times 2, 5 times 5 minus 2, maybe? Something like that. Let's turn off the fog. Get moving. Maybe it was further out. It is 40 million quads now. It was consistent. Remember, I drove away and came back, and it happened again. Which means it was even drawing everything in different order than it had been. I don't know. I guess we'll push it out a little further. I don't think it was could be much bigger because at 5 by 5 I'm pushing the limits of how many chunks I can store at once. Because I can only store 100 chunks. So I don't think it could have been much bigger. Like here, now I'm overflying the... Yeah, it's not even, it doesn't have free chunks to store the stuff in. So I don't think it could have been this big. Because the logic isn't working at this scale. Or it's just lagging. So I don't think it was this big. So I don't know. What else did I change? I added all that debug count stuff, but none of that's active. That's weird. But yeah, I don't think the logic is right. Anyway, we're not freeing up we're collecting chunks that aren't getting freed up when we do that. This needs to do something like this to make sure it frees the chunks that aren't being used. Oh, I see why. We need to actually have 2 copies of this loop. Well, okay, instead of goToDone, we say int has generated equals, well, not int pool has generated. If we get to here, we say has generated equals true. And then if not has generated, then we can generate. And if we do that, then we should be able to push this out bigger. And it'll clear the correctly. Or not. Or I've just generated. Has generated equals false. If not has generated, so false, which is true, then we can generate one. Why is that not correct? Oh, because, yeah. No, that's not why. I don't know why that's not working. Let's see. The work break won't change anything. Yeah, it was intention getting rid of the break, because I want to make sure clear map runs. The other code, the way the code was, the clear maps didn't get run. If you were always generating something, it prevented the clear maps from running. So now the clear maps will always generate. I don't know. I can't get it to happen anymore. I believe that's too big. I believe this will be busted. Although I'm not sure why it's busting like that. Oh, it's generating outside the view radius. I have to change the view radius. This just can be this now at this point. Except that's also outside the far clipping plane. Because we're generating, it's a tiny number of quads. There's still something going wrong here. We're hitting make chunk every time and then clearing it again. Oh yeah, within a single. Yeah, I'm not quite sure. Like I said, this is trying to generate more things than we have chunks for, and the logic just doesn't handle that. So I'm not going to try to figure out why. Like this is already, now we're up to 50 million quads, and it's not failing anymore. So I don't know what that was. Like we're clearly we're flying way too fast for the amount of, for the generation rate at this point. Yeah. No, this is my default development environment. Yeah, I don't know. Can't get it to glitch. All right, so I don't want to do the road network. Don't want to work on the building generator yet. Let's do the height field. It's unnecessary. It's not really the next thing in the queue, but just as a simple thing. So what we'll do is we'll use the existing these things, and we'll have one implicit command at the beginning. So we'll have a height field. A local height field for this thing. Height field 17, 17. We'll actually make it a float height field. And we'll bind that to, I don't know, 3. And then we repeat all this logic. Well, not that part of it, just this part of it. So let's go to here. So right when we start doing the commands, so right here, we want to have this one implicit command that'll use this code. But it, like that. Implicitly, x0 and y0 cover the whole thing, so none of that's needed. Okay, so then z0 is, so we want to sample the height field. So sample height field at x, y. Int px equals x shift 4, int py equals y shift 4, x minus equals px, y minus equals py, float h00 equals height field of py px. Lerp, float h0 equals lerp of y over 16.0, oh no, yeah, y, of h00 and h01, float h1 equals lerp x h11, return lerp at least both y, lerp of x over 16.0 of h0 and h1. So then z0 equals 0, z1 equals sample height field of I should have used vectors for these instead of unpacking them, but it's fine. And we want to convert that to an int. We could round it, but it works out the same either way. So the bottom of this starts at z0, and it extends up to z1. I think all this logic then stays the same. So I believe that will fill the ground according to that height field. So let's try that. So we need a new uniform height field. So where we do occupancy, where's the occupancy one? Occupancy, we do bind buffers height field. Yeah, span to 3. So then we generate a height field, state shader storage buffer. Right. Height field equals create shader storage 17 times 17 times 4. And then we need to build map. So build map is going to call update buffer height field offset 0 size of 17 times 17 times 4 with height data float height data 17 to 17. We won't worry about getting the chunks to line up. Let's just put some data in it to test it. So we say, let's move the buildings up to start at 64. Yeah, we can get rid of this old ground. Have the buildings start at 64. And fill out the height data. J equals 0, J less than 17. Let's make that clear. I equals 0, I less than 16. Height field of J of I equals STB frand. It's probably 0 to 1, so let's make it 0 to 32. Height field, oh, height data, yeah. Now the camera's going to start too low. When I did that cut and paste, I broke something. What's wrong one? This one. Int Z0, int Z1. I haven't computed Z max yet, Z min yet. We don't have a type. We're always command slab for this. We're always the pos2 this has to be pos plus region pos plus region dot x pos dot y plus region dot y. Because every lane is actually computed two different locations on the map, so we need a Z1 alt. Maybe we should just do these as 2 separate loops, actually. If has second. Let me redo all this calculation using Z1 alt. There may be better ways to do this. This part is always in range. This part is always in range. This part is gone. This part is always in range. And Z1 alt is greater than Zmin. If Z1 greater than Zmin. This is blown up horribly. Zmin. Z0 is always going to be, because it's 0. It's always going to be less than Zmin. And these are always going to be bigger. This is not culling correctly. We want the range that we are filling is Zmin to Zmin plus max Z2. Target for this lane is fill range is Z1, Z0 to Z1. So we want Z0 overlaps Zmin plus max Z plus 2. Right, okay, so this should fail as Z0. As Zmin gets big, these should fail. Zmin gets big, these are no longer true because these only go up to the sample. Okay, so let's make these, let's force these to 4 in case we're not getting the data out of the height field, right? Okay, that's right. We're not setting up the textures yet, so it's correct that we get the debug texture data. And then, so if we don't load those, presumably we're sampling the height field wrong. Yeah, that height field is not getting sampled correctly. So there was some logic error in this height field stuff. These should be times 16, or should flip 4. Okay, there's little bits of glitching here, but that's correct because we're not generating the boundaries correctly, actually. So let's make it a little less tall so we can see what's going on better. I want to turn off, I think compile, no, edit and continue, it's not on. It seemed like it was behaving like it was on. Okay, so now we get a nice height field ground with some bugs that I don't understand. Oh, I do understand. Plus 2. The bottom voxel, if you're down at level 0, it doesn't get drawn. I think level 1 should get drawn, but we'll just go up to plus 2 to be on the safe side. Not sure why it doesn't fill in that edge. That gap is what you'd expect because we're not generating the same data on either side. But why do we not draw this row? That doesn't make any sense to me. We definitely, oh, because of that. Yep, somebody in chat just caught it too. Okay, now let's make it coherent. No, let's do the texture first. So occupancy needs this, and build texture grid needs the same thing, but build texture grid works differently. We just have an arbitrary number of things, and the actual arbitrary number we have is 8 by 8 by 4 applied to so I think what we do is we say sample height field of GL global invocation id.x, GL global invocation id.y. We store that to int z. Then we subtract in GL local invocation id.z. So each lane, the location is determined by this for the lane, but we'll run 4 lanes in each column. So we'll set the top 4 textures. We only really need to say 1, but if you have a really steep slope, more than the top one can be visible. So we'll just hard code it for now. X 2 1 0 8 4 2 1. Was that the magic number? We'll set it to asphalt. No, asphalt is 1. Dereference of non-pointer. Oh, that's y times 2. Into uint. Did not work. There's an off by 1 thing, maybe? I remember there was an off by 1. Which we Well, we cut and pasted that code. It might not. No, the off by one happens here, I think. Yeah. Um, well, let's apply the texture a little higher just in case, just to debug and see if that helps. It's correct down here and wrong up here. Okay, that's weird. Are we computing? It's like we're not computing the height field the same. We're not computing the right height field. Region times 8, pos xy, shift right 3. Let's look at the sample the height field in occupancy. Sample height field. Pos.x plus region. And pos.x is offset by region, but then also offset by 1, but that's something we don't have to worry about in the texture. Okay, this stuff is applied to, let's do this. I don't think that'll matter. It really just looks like we're getting the sample height field wrong. Are we getting it wrong, or are we just off in our elevation computation? Okay, let's do this. Let's not subtract. Okay, we're getting patches that are correct. Are they all at the same elevation always? Looks like it. That would imply, I know what it is. We are sampling the height field incorrectly. That is the reason. This is a bug I keep doing. Keep doing it. Does anybody know what it is? This is a mistake I've made many times during this development. You need to bind that in here as well. 3 is in use, so let's put it on 6. No, it'll probably work. Just work fine. Yep, as expected. Okay, so now let's make coherent data, which we can do because we copied in noise from my other thing, so we can use let's use big noise. big noise. What is that? Parameter S? It's a fractional bits, effectively. It's a spacing. So build map. So height data equals big noise of x plus I times 16, y plus j times 16, sure x f7 1 whatever as the seed, and then s, the shift amount, six. And then what does this return? Big noise returns R shift right 12. I'm not sure what the range of the output is. Oh, here it is. Range is 0 to 65535. Okay. So then we divide that by, let's leave it large to start with, just so we can see if it works. Okay, it's going down too low, of course, still as before. And let's make it, allow it to have even steeper things. 10, 12, 4. So we can see that we do have some kind of bug in the logic here for the neighbors. Or for the textures. No, not for the textures. It's definitely for the neighbors. What would that bug be? It's the occupancy. It's the way it handles this transition between the two things, I think. I feel like the high bit and low bits aren't quite right. Right, it's probably at that bit boundary. Let's allow it to get steeper, just so we can check that part of it. That's broken. That's broken in some really weird way. Is it signed? I thought it was. I thought it said the output was 0 to 65535. It did look like it was signed, though. The way it's sticking under it. But it's still doing that even though I'm clamping to 2. There's some bug. There's some logic bug here in how the handling of the occupancy. Wow, I don't know what that though is. There's definitely, this is not right. There's something wrong here. Um, uh, well, we know we're always setting the bits all the way to the bottom. Low bit should always just be 0. So it's weird that that's not quite what's happening in the output, that we see the undersides of things. What would, so bit array index should always be 0, and low bit should always be 0. And the problem is that we cut and pasted this code from the slab code, so I don't know how it could be wrong. Low bit will always be 0, and bit array index 0 should always be 0. Just propagating the z0 equals 0 at the top there, propagating that through all the functions. It should just always be 0. Why would it blow up when it's steeper, though? Okay, is it because it's steeper or is it because it's higher? Let's... 48, so it's shallower. And it's fine. So now let's keep it shallower, but move it higher. And it breaks. It breaks if it goes above a certain height. So since the 0 level thing, like, it seems like it's the Z-min thing isn't being counted for properly, because once it goes above, so the lowest processing covers the first 64 bits, and it looks like it's failing once it goes above 64 bits. It's technically 62. So like if we set this to 62, then I expect it to just always be broken everywhere. Set it to 63 maybe. Or maybe it'll just be broken in the same way. Yeah, so it's not offsetting by the Z-min properly. Did we lose the code that says minus Z-min? No, we do it here. Oh, but then we're comparing to Z-min. That was the bug. Pretty sure. Yeah. Okay. So now we can go back to this. Make it huge so that we can check that sloped walls getting textured or not getting textured, as the case may be. Right, so if it's too steep, we're not doing enough texturing, is the expectation. Because we're only setting up the texture data for 4 voxel stall. Although then I tweak that code, so I don't even know if we're actually doing that anymore. Make texture grid. Okay, here, this one. Okay, yeah, we're still doing it. So it ought to get the top 4. The top 4 should be correctly textured. So it ought to only break if it's steeper than 4, which isn't the case here. It's breaking on the topmost one. Because it's rounding differently or something. Except it should round the same. Right, because it's using the exact same math. Whoops. It's using the exact same math for both of them. Sample height feed pos.x plus region x. Could be off by 1. I don't think it is. It shouldn't be off by 1. But we'll add 1. No, it's still busted, and I don't really understand why. It doesn't make any sense to me that that would be busted. Like, something is going wrong. Okay, what happens if we add 3? So we should only be setting the topmost one and then stuff above it. We should never be seeing, yeah, it's something's going wrong here. Something just isn't right. But I don't understand what. Oh. I don't understand what happened to that either. It's lost my OBS full screen projector. There it goes. Sorry about that. Don't know what happened. Don't know why it forgot. What would be going on here? Also, why do we get these underside things still? Why is it deciding to draw this bottom face here? that looks like the whole thing where we try to we're doing this whole thing where we're only using 62 of the 64 bits to try to make sure we don't generate false data at every 32-bit boundary. And that looks like it's not working correctly with this data, which might mean it's not working correctly on the slabs as well, and I just hadn't noticed. So, but that's what that data is that we're seeing. The spikes underneath and stuff. But why the texturing isn't working correctly, I don't know. That's a separate issue. And one that only happens with the extreme slopes. Even this is more hilly than it should be. So we do S goes up to 7. No, I know. We'll just do it. We'll just do it here. So relatively subtle. Why is this so slow now? Why is my movement speed so irregular? What is happening? Do I have some other app running? Has OBS decide to suddenly slow things down? If we break, where will we be? Annoying. Is it sprintf? Okay, well, let's just restart it. Let's see if that was. No, we're getting really erratic performance now. So let's disable this code. No, it's erratic. Let's do this code. Still erratic. Let me exit OBS and restart it. Still erratic. Make sure it's not this, the fact that we're generating so many. I don't think it is, though. Oh, maybe it was. It was just terrible. The frame rate was so terrible from having too much data. Is this for a specific game you have in mind? It's a remake of an older engine that had a specific game in mind, but I haven't decided what game I want to do with this. Okay, so now we can move the buildings back to the ground. In the future, of course, we'll actually make them flush to the ground, but for now, we'll just do 3. And let's add a CSG erase at the start of the building. P equals put erase base P x0 y0 z base x1 y1 z base plus 3. We won't erase the full thing because we don't want to waste too much time. But this will erase the ground where the ground stuck into the thing, hopefully. Yeah. Yeah, like here you could see that the ground used to stick into the building here, and now it doesn't. In fact, we can do big noise. Shift by more. And divide by even more. Actually, divide by less. So now these floors should be underground, but we need to actually erase more of them. Yep. So now this is the beginning, so if you can see that we could actually put floors of the building that are below the ground level. So we can have basements. So it's just the beginning of showing how that can happen, but using the CSG stuff. All right, I think that's a good stopping place. 7.5 hours. Any questions? What's this for? It's just making an infinite voxel city. Do you ever have problems with your NVIDIA cards failing? I don't think I've ever had an NVIDIA card fail. Doesn't mean it's not a problem for a lot of people, but it hasn't been for me. It's just for fun. I mean, it could turn into a game. Who knows? But it seems it isn't too hard as long as respecting invocation IDs. Oh my gosh, if you watch the full, all the streams, you will see so many nightmare debugging problems with compute shaders. I mean, it doesn't help that I'm using OpenGL in Windows 7, so I have no ability to debug shaders, but this is running on a 980 Ti, so I don't expect it to hit ideal frame rate. That's why the horizon is not very far. We'll on faster cards we can push the horizon out. So yeah, it should run at 60. The goal would be to run at 68 frames per second on good hardware. But you'll just be able to set your view distance, and that'll determine the frame rate. So even on good hardware, if you put the view distance out further, you'll come down to 30. So yeah, so the next step is I need to finish going through my texture assets and get a set of textures for this, and then we can start making the building generator actually generate with real textures that are appropriate and varied. So that will unlock that. Once I do that, we can unlock doing real building generation. In the meantime, separate from real building generation is real map generation, meaning generating the city road network, more like this old project. That takes a long time to start up because I have to run it in debug because it's broken in release. So here's the old version of this that's generated on the CPU. It doesn't use compute. And if you look, you can see that the roads do some fancy stuff that makes the blocks more complicated. Like down here, you can see that it's not a simple shape for this block. It's pretty complicated. You know, the roads are the asphalt, and then intersections are the gray. Right, and so this block has been filled in by these buildings in a pretty complicated way. So I want to get that kind of logic again, and that starts with building the road network. So so that's definitely a next step as well. I've done almost all of this. It's not necessarily final, but it's close enough to final. Yeah, I don't think there's anything in here now that we haven't done. So yeah, so the main thing is this is Voxel Week because this is a project I used to only work on Fridays, so on Voxel Fridays, I called them. And so for Voxel Week, I'm going to just work on this project this week. And so what we're going to mainly try to do is get the city generation working, which is both building generation and the road network and lot floor plan layout working. All right, last round of questions. Yeah, navigable building interiors is definitely a requirement. I don't know how I'll do it at all. I have no idea. Oh, in the current thing, we are generating. We can generate staircases, and we generate an empty elevator shaft. Uh, Except I apparently disabled the elevator shaft. Uh, yeah, at some point I accidentally deleted the elevator shaft call. Um, equals make elevator shaft base p x minus 6 y minus 8 x plus 8 y plus 8, I think it was. Z base. The z base plus floors times floor height. Okay. Yeah, so just an empty elevator shaft, but we can put an elevator in later if that makes sense. Maybe there's a ladder so you could climb the elevator shaft. You see that in DayZ. Where's my mouse? There it is. There is no map seed currently, although that's certainly a possible thing. But it's infinite, so there's no map size because you just ask for a chunk anywhere. I mean, it's limited by 2 to the 32, I guess. But you ask for a chunk anywhere in that 2 to the 32 space, and it can generate for you. Of course, it's not coherent. It's not generating chunks that match each other neighbor to neighbor, except for the ground texture. The ground height is being done that way. So that's why the ground is, I mean, it's not very sophisticated, but it is continuous, even though it's actually being chunked. Uh, I mean, up to 2 to the 32, you shouldn't see repeated patterns. And probably just stops at 2 to the 32. So it's probably 2 to 32 is 4 billion. So it's either 4 billion feet by 4 billion feet, or 256 is what? 100, about 80 meters. So it might be 320 billion meters by 320 billion meters, which is 320 million kilometers by 320 million kilometers. Let's do this. Area of surface of Earth. Total surface area of Earth is probably approximately 510 million square kilometers. Oops, I did not mean to click the button that slows the thing down. So we go to calc. So then we take 510 square kilometers and square root it. That's 22. Oh, wait. 510 million. 3, 510 million square kilometers. 510,000 there. That's 510 million. Square root it. 22,000 kilometers. So 22,000 kilometers times 1,000 is 22 million meters times 3 is 67 million feet. So even if we only go 2 to the 32 feet, that's already larger than the surface of the Earth by a lot. So yeah, while it technically would repeat beyond 2 to the 32, I mean, you could always go to 2 to the 64 too. I'm currently 32-bit, but if I shipped it, it would be 64 as a 64-bit app. So you could do the math on the 64, but it's just it would never generate. You would never have any reason to generate missions out that far. So as long as the player can't just pick an arbitrary number to teleport to, you probably wouldn't ever let them. Like in Minecraft, you can walk to the edge even without teleporting if you spend a couple weeks. The old Farlands from the 32-bit version, but if this was a server only game, then the server wouldn't let you walk that long. So you would never see the edges. But yeah, bigger than the surface of the Earth, I think, is a fair enough by a huge factor. I guess we could say how big a factor. So if I didn't screw up the math, it's 67 million feet squared. So we could go to 32-bit, which is roughly that. So 1% on both axes. So it's 10,000 times bigger than the surface of the Earth is my estimate for what it would be by default. If I do the simple thing, I believe it would be unique to that size, which is way more than the game would ever actually use if it were in a game. Okay, let me catch back up on what's in here. Okay, people talking about other stuff. Do I plan to create an LED system for buildings? No, I plan to have fog that hides them. On the faster GPUs, it's just not a performance problem. But we have talked about what you could do, but it's kind of gross. You would see popping, and I don't like when you see popping, so I'd rather not. Oh yeah, this wouldn't be the real color of the fog, but I don't know that I want spooky fog. I think it would just be gray fog. Here, the blue fog is just to match the color of the sky. It's real fog should match the color of the sky, and the sky was already blue, so I just matched the fog to the sky. The right thing to do would have been to make the fog gray and turn the sky gray as well. Right, because the sky is just the color of the fog. The sky is just so far away that all you see is the fog. Effectively. And so you ought to always just see the fog color as the sky. Although looking up, you're looking through different medium thickness, so it does change. Like real fog is directional, but not for this hack. Okay, really lost train of questions. what kind of game was going to be made with the original engine? I was thinking about making a. It would be a little like Helldivers 2. The engine predated Helldivers 2, but so player versus enemy team game, but with larger teams than Helldivers, like teams of 10 or 20. So it would be a pickup team rather than a drop. Rather than dropping together, you could drop in and drop out, join a team that's working on a mission in progress. That was sort of the idea I had for it. And so it's a big continuous city. So you could drop in on a mission that would be somewhere in the city, and then there might be another mission somewhere else in the city, and the two could potentially run into each other because it is a continuous city. It could even be that there's like a sort of a common thing where like one team is working on a mission to unlock a thing, and another team is headed towards the thing that will get unlocked indirectly. You know, one team is trying to flip a switch that you know needs to happen before the other team can get through a particular area or something. No, so it would still all be cooperative. The teams are helping each other against a common enemy. That's a AI. All right, that's it. Thanks everybody for being here. As always, all of these streams are on YouTube at higher resolution. So the world will only generate once there is a dynamically generating at the gameplay loop. The world is being the details of the world are being generated on the fly, but they're from a seed student random, so they're always consistent. So it would always be generating the same stuff at any given spot. All right. Thanks for watching. See everybody later. Maybe streaming every day this week. I don't know.